Hello everyone, welcome to ZaranTech. In today's digital era, data is the lifeblood of every organization. SAP Data Intelligence enables effective data utilization. Let's explore its significance in today's data-driven world. In simple terms, it's a comprehensive data management solution that allows organizations to access, process, and analyze data from various sources all in one place. Think of it as your one-stop shop for making sense of the vast amounts of data swirling around us. By 2025, about 463 exabytes of data will be generated daily worldwide, akin to 212,765,957 DVDs daily. In this data-driven era, SAP Data Intelligence is vital for businesses to remain competitive. With it, organizations can harness data for innovation, efficiency, and profitability, making timely and accurate decisions in the dynamic business landscape. In this course, we'll cover everything you need to know about SAP Data Intelligence, from its core functionalities to real-world applications. We'll explore how it helps businesses streamline their data processes, enhance decision-making, and stay ahead in an ever-evolving digital landscape. So, buckle up and get ready to become a data intelligence expert. Before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now, let us take a look at the agenda. 1. Why SAP Data Intelligence? 2. What is SAP Data Intelligence? 3. Architecture of SAP Data Intelligence. 4. Evolution of software development. 5. Kubernetes overview. 6. Services in Kubernetes. Let's dive in.
Hello everybody, thank you for joining the 4-day SAP Data Intelligence training. My name is Ganesh and I will be taking this training along with my co-trainer Venkat. So let's start with a round of introductions. So I have close to 13 years of experience. I have been working in SAP and non-SAP technologies mostly. And for the past few years, I'm working in the cloud data integration area. And I'm also a certified cloud architect. And which is where, data intelligence also intersects in a big way because it doesn't just touch SAP, but also touches with the non-SAP world, right? And which is why I've been working in this area for more than a year now and have already participated and implemented projects in the past. And yeah, I'm happy to share some of my knowledge with you and take this training forward. Okay, Venkat, you can begin please with an introduction.
I have close to about 12 years of experience and predominantly with SAP. And I have worked in multiple SAP solutions like SAP Business Objects, SAP Lumira, SAP HANA, SAP C4HANA, SAP Data Intelligence, SAP ERP, etc. So the list keeps going on and on. And I'm also a cloud certified architect. I'm certified in AWS and Azure as well. So first of all, I would like to welcome you all for this. Yeah, I start with this slide. So what is it? So why we are having this statistics? So why it is so important? Now, after the statistics, we are also cover the Docker's hands-on for 1.5 to 2 hours. So why I need to learn Docker? Why I need to learn Kubernetes? So people see, I am an SAP. I am a long-time SAP. Okay, so it took me some time, to be very frank. It took me some time to adapt to this new technology because DI is based on an open source technology. So we have Kubernetes concept, we have Docker concepts, but we need to learn these stuffs in at least not in depth, but at least to debug a little bit. Now tomorrow, in case if you are going to work on something, you need to know how data intelligence is placed. We will go in depth about the architecture also. I will show you how it is placed. But yes, you need to know what is a Docker container, how to create a container, how to build an image, what is a Kubernetes, what is a pod. So these are all some of the basic stuffs, and with hands-on, if I tell you, you will never forget it in your life. So this is that is the main agenda here, and this is very, very important. See, some of the trainers, they might not concentrate on this, but I personally feel there is a level of concentration that is required. Now, one more advantage I will tell you. So on the day 3rd, Ganesh will be showing you some pipeline operators. Now, we have a very big reason behind this Docker images because you can build your own images out of the custom operators that we are going to build, and Ganesh will be taking you through that. Now, without knowing this, if you directly go and pull some images or push some images from the pipeline modeler, how it's not It will not work, correct? Now, most of the people don't know this, but so we will just establish a strong base, and then we will give you all the basic knowledge about this new technology, about this new solution. Now, from a mindset perspective, right? So you people are from SAP. From a mindset perspective, 50% you keep the SAP knowledge, 50% you just leave it blank and try to grasp whatever we are telling now. Because tomorrow we have ABAP integration, SAP Cloud Connector. ABAP integration is going to take 1.5 hours because it is not so easy, and you will learn the complexity why it is not so easy, right? So with saying that, we will start with the overview. What is the purpose that SAP has come up with this SAP Data Intelligence solution? What was the requirement? Why all of a sudden SAP has to come up with this solution? So because 86% of the enterprises claim they're not getting most of the data. Okay, these are all some of the statistics. 72% of the survey participants, they are yet to forge a data culture, right? So since you guys have been working with BobJ, data services, data warehousing scenario, but you actually have a business demand. Do you know what the customer actually wants to do with it? Okay, we have the normal data warehousing scenario. We pull in the data. Okay, we build the reports. But what is it the customer is actually looking out for? Okay, as a CIO, if I am the CEO of a company, I need to look at the financial reports. Fine, the financial reports are fine. But the current trend, right? The current trend demands even more than that. Okay, my report shows this. What I have to do afterwards? So that is what is really missing. That is why most of the organizations are failing, even though they have everything, right? Now, organizations who says that we have everything in place, they don't have everything in order, right? So we call it as a data silos. So being in the data warehousing team, you should be knowing this, right? Now, what is the solution that SAP has come up with? So the solution is SAP Data Intelligence. Now, when I say 8.5 out of 10 early data science initiatives fail to get to production, 86% of the enterprise, they are not getting most out of the data. Why? So there are few reasons, why these are failing, why these statistics are given by the report. So we took it from Forrester report, we take it from Gartner report. Why? So the main reason here is, number one is insufficient, incorrect, or conflicting data. Okay, so that is one of the main reasons, which we will put it simply as data problems. So now I have shown you a few statistics, correct? Now, what is the major reason? So we have, if you do a Google or if you do anything, you will have n number of reasons, 20 reasons, 25 reasons, but everything, if you see, it will link to only one problem. So that is your data problem. Okay, so now what is the second one? Second one is nothing related to technology, is nothing related to any solution. It is failure to understand business problem. Okay, so what is the business problem that I am trying to solve here? So that is the main goal, which is missing between many organizations. Okay, so when I say data problems, it can come to poor data quality, the accuracy, the data silos. Now, many of the data scientists, they feel that not a quality of data that has been provided to them. So that's why the data science projects also is failing. Now, even in a common scenario, as a CIO, if I have the report of financial data and data is not cleansed properly, data is not available properly, obviously I would have an incorrect projection of what is going to happen and what has happened already, correct? So data quality, data accuracy, these are all some of the important problems that organizations are failing to solve. Now, you can argue, we can debate, saying that, yeah, organizations have their own solutions to cleanse the data. Say, for example, we have data services, we have Informatica, we have a lot of other solutions in the market. You do this, we have the ETL process. But yes, but what it leads to is, it leads to data silos, right? If a customer is having n number of data sources, but what is the data that they have to retrieve from all these data sources? So this, just how can we eliminate all these data silos? So is what we are going to see in depth, how data intelligence will help in addressing all these data silos, how we can build a proper governance model, so which will be helpful for all the people, say like data engineers, data analysts, data scientists, whomsoever you call it. So data steward, okay? So it will definitely act as a single platform to eliminate the data silos, to provide a appropriate data quality solution, and one platform for all the data people. So a lot of advantages are there, right? So this is one of the main reasons that we need to understand why the failure is happening. People will tell failure has happened, but why? It is because of the data problem and the failure to understand the real business problem. The first and foremost, very important question: what is the business problem that I'm trying to solve here? So these people have to come together, they have to discuss, and then they have to come up with a problem solution. And this is the one that we will be able to use it. Okay. So as I told you, enterprises are struggling with complexity. Year on year, 68% of the organizations, they are reporting a growth of 10% of data. And 71% they are using more than 6 data sources. Right? Gone are all the old days where we use the traditional databases, one-to-one mapping. No, 71% of the organizations, they're telling that I am using more than 6 data sources. This is what my current scenario is. So imagine the amount of data silos that are already prevailing, right? So how are we going to solve all these problems? Now, these problems, what does it lead to? It leads to business disruption and productivity loss. Right? So obviously, you will have a business loss. You will have your production will not go as expected. Okay. So these are all some of the statistics. Say, for example, business disruption, it had costed around $5 million and productivity loss of $3 million. So these are all some of the projected statistics that we have taken from Gartner or Forrester report. Right? So how much money you could save if everything is in place is what the ultimate goal is, right? See, for everyone, what is matters? Say, for CEOs, for CIOs, what is the ultimate thing that they are worried about? It's about the money, right? If proper data governance is not in place, how much money is I'm going to lose? So that is what we will be covering in the next slide. So enterprises are struggling with compliance, and you can see the comparison between 2011 and 2017. So there has been a loss of $1.07 million in 2011, and it has always been increasing. You are able to see any chart which is decreased? No, right? So it has always been on the increasing trend for any organization, because year on year, what we saw is there is a data growth. Okay, there are a number of data sources keep on increasing for an organization. So when you say number of data sources is increasing, so the complexity is also increasing. When the complexity is increasing, obviously data governance, model, compliance management will also increase, and there should be a mechanism in place to address it as well. And if that is not there, this is what is likely going to happen. So you will end up in losing a lot of money, right? So now, we have talked so much about data now. We have talked so much about data. Let's just take a step forward. Okay, now, as I told you, I'll just give this example. As a CIO, I'm seeing the financial report. Now, what is the next step I have to take? If I give the CIO a prediction analysis, my forecast analysis, okay, so this is what my sales is going to be for the next 5 years. Now, this is what my revenue is going to be for the next 3 years. This is the profits. So, some kind of good predictive statistics. So that will help the CIO to take a decision appropriately, whether to close down the business which is not doing well, whether to expand the business which is going well. So some kind of business decisions, CIOs will be able to take it. Now, just some statistics of how machine learning and artificial intelligence have helped big companies like Netflix. So how much has Netflix saved this year? So it's $1 billion. So have you ever come across people who have been using Amazon Prime Video, Netflix? So there will be movie recommendations, right? So these are all nothing but behind the scenes machine learning algorithms are working on its own. So based on the type of movie that you choose, the algorithms will run. And obviously, when you open the Prime Video or Netflix next time, you will be given a choice of movies that you like. So which, as a personal, I have literally taken advantage of the recommendations that these guys have given me, because say, for example, I really love horror movies. When I start seeing some 2 or 3 horror movies, automatically in the recommendations only horror movies will come. So as days go on, when I see adventure films, when I see action films, so instead of 10 horror films, it will come down to 8 horror films and then 2 adventure films. So this is how the ML algorithms will definitely work. Now, what happens is, this is not only about the ML. Okay, behind the scenes, ML algorithms is also working, but it is about embedding the statistics internally, right? So there is a heavy usage of analytics internally. What it does is, it gives you the recommendation. Based on the recommendation as a user, if I go for a movie, then internally what will happen is, say Netflix or Amazon, they will have a report. Okay, so this many users have subscribed to these many movies based on the recommendation that has been provided. So when I give it as a report, say for example, when I use business objects, when I use SAP Analytics Cloud to connect to the database and then retrieve these reports, for sure I know that my ML models are working fine. My ML models are accurate. Based on my ML model, these many users have subscribed. The subscribers have jumped from 10% to 20%. Right? So this is what it will lead to. Right? So it's not only about ML model being running in the background, helping you to choose the required movies, but ultimately, internally for the companies, you will be able to build some good dashboards, which will tell the statistics to the CEO or CIOs in terms of revenue, profits, subscribers, etc. So everything is interlinked, guys. So you just have to understand one thing: everything is interlinked. Okay. So I will explain you more in depth when I say interlinked. When you talk to outside people, okay, I can guarantee you that when you talk to outside people and go and tell them about SAP Data Intelligence, the very first thing that will come to their mind is, yeah, it is a machine learning and artificial intelligence tool, right? That's what they will think, because that is how it has been projected. But unfortunately, that is not the case. It is just one pillar. Okay, so it is just one pillar. DI is all about managing the data flow and its landscape rather than having anything in isolation. So data orchestration, data governance, machine learning, artificial intelligence. How do you link? How do you link? So this is very, very, very important. Now, tomorrow my requirement may be only data orchestration. Say one customer example, me and Ganesh, we were working for a customer, which Ganesh will tell it to you during the real-time customer use cases. But just to bring up the concept here, so that was only pure data orchestration scenario. No ML and no AI involved in the initial phase, right? So it was pure data orchestration. Now, when they were happy with the data orchestration, we had a meeting with the top level business management colleagues. They said, yeah, we are happy with the data orchestration. So what should we do next? Correct. We have the data in place. We have the quality. We have everything set. What is the next thing? Yes, next thing is building the appropriate ML models out of the data that we had already consumed in DI. Right? So this is what you have to understand it, guys. So DI is not only about ML and AI, it is about managing the end-to-end data flow and its landscape rather than anything in isolation. Okay, so as you can see from the slide, a lot of companies have saved a lot of money based on implementing the proper and the right ML and AI algorithm. Okay, so this slide, the concept that is being presented here, you guys must be very well aware of it because you guys are working on SAP data services. But what is really happening here? Okay, so we have disparate landscapes, various data types, and manual reload operations, right? So you have ETL operations that has to be performed on various sources, right? On various sources, and then you have to put it in a data warehouse, and then you have to connect the appropriate reporting solutions to build the report. So this is a normal. This is a normal or the traditional approach. Even today, most of the companies are following. Okay, but now time for us to come to step up and say, hey, this is the normal flow. What is the new flow? Or what are all the requirements, right? So if the customers ask, who has changed what data? What has been changed? Who is accessing it? So from a data governance perspective, what should be your answer? How do you compare your traditional data warehousing technology with the modern SAP Data Intelligence? Data sharing, how collaboration is happening internally in case if you're using data services or information steward, so or even for that factor, SAP Agile data preparation. So how is the collaboration is happening internally? If you have a data set, will I be able to see the data set? Will I be able to put some comments? Will I be able to rate it? How the collaboration is happening? And how easy or difficult it is to create a pipeline, right? So in data services, you will be creating the data flow and you'll be having a lot of data flows, connected to a lot of source data sources and then target data sources, doing some transformations. How easy it is to create a pipeline, how easy is to manage a pipeline, how easy is to monitor the pipeline, how easy it is to schedule the pipeline. So these are all some of the questions, that we need an answer for. And yes, we have the answer in terms of a solution called as SAP Data Intelligence, right? So now we have something called as intelligent applications. Okay, so we call the S4 HANA as intelligent enterprise technology. So how the applications are going to behave intelligently rather than it's a normal application, right? So the application should be able to provide me some insights, okay, with all the sophisticated features that are already available. So it should be able to provide me some good insights. Now, what are all the roadblocks for you to develop intelligent applications, right? So data availability. Now, assume that you put yourself, okay, so forget everything. You just put yourself in the shoes of a developer. You're developing an application. Now, you want that application to be a little bit intelligent, okay? So when I say intelligence, yeah, good insights, meaningful insights. Okay, people will normally say only insights, but I would really stress on the word meaningful insights, because that insight should really give some value to me. See, when you're working on developing an application for ticketing mechanism, it doesn't look good if I provide you an insight saying Sachin Tendulkar has scored these many runs. Obviously, yeah, it is an insight, but still you're creating a booking application, but the statistics or the insight is about cricket, so it doesn't relate. So it should provide you a meaningful insight. So for that, what are all the things that we need to manage? Data availability, yes. Sorry, as I had told you, data availability. We have a lot of data sources. How we are going to manage all the data from all the data sources? Now, first of all, the very first question, what did I discuss when I told you about why enterprises are failing? We have to solve a business problem, right? So we have identified the business problem. Now, the first question is, do we really need to access all these data sources? Some of the data sources might not be even in use for years, but just because for having the data sources, do we need to, access it, right? So, first we need to understand that, right? So data availability. So first find where is the appropriate data that are available. Now, second one is data quality. Now, how we are going to manage the quality of this data? I told you, right, why data science projects fail. One of the main reason is it doesn't we are not providing a proper data, cleansed data to the data scientists, okay? So data quality mechanism also plays an important role. Now, we have the performance. Right now, if you have your pipeline running for hours and hours, obviously it doesn't serve the purpose. Right? I can create a pipeline, I can run it for 24 hours, and after 24 hours, I'm giving you a result and say the pipeline has failed. So it doesn't really serve the purpose. So your performance has to be improvised. Your performance has to be really fast. So why do you think people are moving to HANA? So you guys are from HANA. You've been into HANA development. Why you are doing HANA development? Right? So because of the performance, one of the main reasons is performance, because HANA is an in-memory based technology, right? So now performance is also one of the important factor to be taken care of. Now we have maintenance, we have to maintain the system properly, whatever we are going to bring in, how complex or easy to do an initial setup, what are all the data governance mechanism that we are having. So this is very, very important, data governance mechanism, which I will show it to you in tomorrow's session. We'll have a lot of hands-on there. I will show you the end-to-end flow. So data governance is also one of the important factor. Data integration, guys, this is very, very, very important. Data integration. Okay, so data integration. What do you mean by integration? So how do we integrate with other system, be it SAP or be it non-SAP system? So what kind of integration facilities that my application is going to provide? So someone said that they are working in SAP Cloud platform, right? So we use SAP Cloud Connector for integration. So how easy it is to set up the Cloud Connector? How easy it is to connect from a cloud application to an on-premise? What are all the things that we have to do? So data integration is also one of the important factors that we have to consider. Data processing. So how easy it is to how easy it is for me to use the operator. So define a custom operator and then put it in the pipeline, execute it. How easy it is. Now scalability. All right. Now for scalability, we should have an auto scaling mechanism. So now in case if you're an intelligent application developer, all of a sudden your application is becoming a very big hit. Okay, it's become a very big hit. Now the next day, thousands of users are accessing your application. So your database should have the capacity to handle thousands of users query. You shouldn't throw an invalid server request. Your application should not break down. It should be intelligent enough to automatically scale based on certain parameters. Now model creation and training, yes, the system should be capable enough to enable you to upload your own models or build your own models and then have a training mechanism. and you should be able to train it as well, guys. So these are all the roadblocks that are available in building and delivering an intelligent applications. But guys, you know what, the best part is data intelligence has already taken care of all these roadblocks. It is a one-stop solution. Okay, so all the modules of DI are mapped to each and every box that is shown here. Now, so we will just go a little bit in depth to the definition of SAP data. Now, before going into the definition of SAP data intelligence, what is the definition of SAP data intelligence? Right. So if I ask you to define SAP data services, you will just define it in one. It's an ETL, data integration plus data quality, right? SAP HANA in-memory database, SAP BW data warehousing solution, SAP Analytics Cloud reporting solution. So in a similar fashion, in a similar line, what is SAP data intelligence? So SAP data intelligence is a comprehensive solution to deliver data-driven innovation and intelligence across the enterprise, right? So the main keywords: deliver data-driven innovation and intelligent applications across the enterprise. So we have seen, right, what is an intelligent enterprise, what are all the roadblocks that are there to deliver an intelligent enterprise application, and how SAP data intelligence has all those mechanisms in place to avoid all those roadblocks. Correct? So it is a one-stop solution. It's a one comprehensive solution, right? So you will be able to create powerful data point. Let me just check whether pointer is there. Yeah. So you will be able to create powerful data pipelines. Okay. So powerful data pipelines, advanced machine learning capabilities, and then a comprehensive feature to access metadata across the entire organization's landscape. Guys, there is one very important difference in metadata catalog of SAP data intelligence. Not metadata catalog, but as a metadata feature, there is one important difference. I will tell you this difference tomorrow, probably in case if there are some slides which are coming, I'll just try to accommodate that. It is very important. You should know the difference. So if someone comes and asks you, what is the difference between data services and SAP data intelligence, right? From a data orchestration perspective, so this is one very important difference, which I will tell you, which I will explain it to you in detail. Okay, so you have to keep that in mind. Now, what we can do with SAP data intelligence: access and connect data, govern and discover data. Yes, we can do a data preparation. Absolutely, yes. We will be able to build flexible pipelines. Yes. Then we will be able to deploy and integrate intelligent applications. Okay. And then we will be able to monitor and orchestrate the entire end-to-end life cycle of an application or a model. Okay. So this is what the definition of SAP data intelligence. So you, number one, create powerful data pipeline. Number two, advanced machine learning capabilities. Number three, comprehensive metadata management of the entire organization's landscape. Okay, so this is what the definition of SAP data intelligence is. Right. So one tool to set up, manage, and automate a continuous life cycle. Okay, so I will just like to stop here and give you one example before proceeding further. Guys, there are a lot of other solutions as well in the market. Okay, so Venkat, you're telling me about pipeline creation, you're telling me about machine learning capabilities, you're telling me about all those other stuff. Okay, but aren't these available with competitors? Right? Say, for example, we take AWS, we take Azure, we take GCP. Okay, so SAP has a very tight integration with the cloud solutions as well. Okay, but at the same time, if you have to use the solutions exclusively from the cloud, like AWS or Azure or GCP, you can use. Okay, I will not deny that there are no competitors. This is the only solution available in the market. I will definitely not do that. You can use. There are, even if you ask me, I can show it in the cloud also. See, these many solutions are available. But the problem is, so they are all individual solutions. You don't have a single solution to manage, monitor, create pipeline, build model. You don't have a single solution to do all these steps. You have a separate solution in cloud. Say, for example, in Azure, you have Azure machine learning model. For ETL process, you have Azure Data Factory. For storage, you have some other things. So these are all different solutions. So what you have to do is, you have to build each and every component separately in each of these solutions and then connect them together. first of all, you have to connect these solutions together, and then only you can think about integrating with any other SAP or non-SAP solution, right? So this is what the major drawback with our competitors, and that is why SAP Intelligence is gaining popularity. It's a one-stop shop for everything. So pipeline creation, orchestration, machine learning, monitoring, whatever it is. Yes, whatever it is done. Okay, so as you see, we have the connect phase. We will be able to connect to any kind of database that is available, and I will be in the connection management. I will be going through the list of connections that are available. So guys, on one more important factor, connection management might look little bit simple, but it is the most important pillar. Okay, connection management is the most important pillar of this entire data intelligence. It might be a small component, but this is the most important, because without connecting to any data source, you will not be able to do it. You will not be able to do anything. I mean, at least from a data orchestration point of view, you will not be able to do anything. So we will be able to connect to streaming data like Apache Kafka, and then we will be able to connect to structured data, your traditional databases like Microsoft SQL Server, you have HANA, any database, right? And then you will be able to connect to any big data sources for capturing the unstructured data. So your connect phase is already set, like how your data services almost supports all the databases that are available in the market today. So SAP Data Intelligence is also able to do that, but still the connection management is an evolving topic. They are adding more connections. Sooner and later, they will be adding the connections. But as of now, whatever database name that you take, at least the major ones will be able to easily connect, right? Now we have the orchestration portion. We have the the agile data preparation. Now it is not available. So we are trying to bring in the SAP agile data preparation features into data intelligence within the metadata capability. So we don't have an people have come to me and asked whether agile data preparation is integrated with DI. No, agile data preparation is not integrated with DI. But still, the capabilities that are being provided by agile data preparation, at least I think 50 to 60% of the capability we have within the metadata feature in the data preparation phase, which I will be showing it to you tomorrow. Okay. Now we have the other stuffs like machine learning, deep learning. You will be able to deploy the model, which Ganesh will be taking you how to deploy the model, how to train the model. Some use cases he will be able to show it to you. So this gives you an entire life cycle. Okay, if you see, this is an entire life cycle. What do you mean by life cycle? So using the connect phase, I connect to any database, I get the data, and then I do an orchestration, then I prepare the data, I enrich the data, I cleanse the data, and then I build a machine learning model, and then I do a deep learning analysis on top of it, and then I run the pipeline, and then I monitor it, and then later on I can even send it to SAP Analytics Cloud for the reporting purpose. Okay, so this is an end-to-end model for the entire SAP Data Intelligence platform. Right. So, and one more trivia here. People, we have two new solutions, right? One is SAP HANA Cloud, and another one is SAP Data Warehouse Cloud. So, I don't know how many of you are aware of these two new cloud solutions, but SAP Data Intelligence is embedded into SAP Data Warehouse Cloud. Both SAP Analytics Cloud and SAP Data Intelligence is embedded into SAP Data Warehouse Cloud. Okay, so this is a trivia in case tomorrow, if you have any opportunity, or if you have any projects coming in for working in Data Warehouse Cloud also, you should not be surprised. Hey, why Data Intelligence is there? Yeah, it is embedded into Data Warehouse Cloud, right? So that you can also consume the data that has already been put up in the Data Warehouse Cloud using the DI, which is already available within the Data Warehouse Cloud. Okay, so we have how do we bring the enterprise applications and intelligent technologies together, guys? All these while you have been working with big data. I mean, I'm not sure whether you have worked with big data, but based on the experiences, you would have a lot of experiences working with traditional database technologies, right? Have you ever thought about a situation? We call it as X data, and we call it as an O data. That is operational data plus experience data. Usually this will be used in Qualtrics for getting the experience data. But I just wanted to check with you, have you ever used in your environment for both combining your operational data and experience data together and then bringing an output? Okay. One example is say for example, you have an operational data, number of products. Like I have, say for example, laptop 25 products, I have mouse 50 products, and then uh, you are having your own e-commerce application. Okay, you have your own e-commerce application. Now what I do is, in your e-commerce application, right, behind the scenes, obviously SAP ERP is there. I'm ordering a product, I have put it in the cart. Okay, I have put it in the cart, but all of a sudden I'm just exiting the cart. I'm not placing an order, I've just put it in the cart and then I'm closing it. Now you want to understand why people are placing this particular product in the cart but are not ordering it. So if you have to take a statistics, okay, what would be the statistics is, what is my item name? Say for example, it is a Lenovo laptop, that is my item name, and the specifications and all those stuffs will be there, because Lenovo will have a lot of specifications, right? So Lenovo laptop, my specifications. Now if you have a report telling you, giving you an insight on both your operational and experience data. So this is how it would look like. You have Lenovo laptop, the specifications, and number of users who have added this product to the cart, and the number of users who have ordered it, number of users who have logged out, and the most important factor, why they have logged out. Okay, so with Qualtrics, what you can do is you will be able to give a survey. If you're closing the cart, it will give you a survey why you're closing the cart, because the price was high, or probably specification did not match your requirement, etc. If you open your report as a business head, if I open my report, I say, okay, for this particular Lenovo product, people have 1,000 users have added this to the cart, but only 50 people have ordered. Why the rest of the users have not added? If I see why, the reason, my graph will show because of price, or because of transport, or I mean the delivery cost, or because of some other reason. So I will be able to take an immediate action. When I say immediate action, say for example, if I have a graph which is giving me, which is telling me that 900 of the users have opted out because of delivery cost, what I will do is, for these 900 users, I will give them a special discount. I will not give them any transportation or delivery charges. So next time when they see delivery charges as zero, the probability of buying a product is very high. So this is what today's scenario is, guys. Okay, gone. I mean, I would not say gone, but the industry is moving towards the combination of both operational data and this excellence data. So this is just an excellence data. You can also have the big data coming in place. You can have the sentiment analysis that could be performed for a product that you are manufacturing. So there are a lot of things that could be easily done here. Okay. So that is what is being given here. So your enterprise applications, you're managing your intelligent technologies, and then your data management, right? So let me just move on to the next piece. Okay. So this is an high level architecture of your SAP Data Intelligence solutions. Okay, now just give me a second. I'm having some trouble with my mouse. Yeah. Okay, so what is it that you can infer from this diagram? Okay, what is that? I'm able to get this from this diagram. You have three main factors, like I had explained to you multiple times. Data governance, right? Data governance, data orchestration and monitoring, data pipelining and processing, and we have what is it? So we have data governance, we have data orchestration and monitoring, we have data pipelining and processing. Okay, so this is the end-to-end data integration and processing. I will tell you about SAP strategy, guys. Okay, so from here, the whole SAP strategy about SAP Data Intelligence is clearly flowed out. Okay, so you have ABAP integration to connect to SAP applications. You have BW integration to connect to BW systems, cloud integration to connect to various SAP cloud systems. We have workflows to execute the workflows remotely, and then we have APIs to push it to SAP Analytics Cloud. Okay, and on the right hand side, if you see, we have the distributed and external data systems which we can connect to and pull the data. Right, we have cloud storages, we have normal databases, we have public clouds like AWS, Azure, etc. And we also have the SAP Cloud Platform connectors, which we could use for integration. Now, what is SAP strategy is one solution to connect to anything, one solution to connect to anything, right? And then do whatever is possible. Data orchestration, data pipelining, model governance, model training, push it to any of the third-party sources using APIs. Everything should be possible. Now, what is the strategy that I could find here is one solution, okay? One solution to do all the capabilities that an organization requires. One solution to provide a tight integration with the SAP application. But I'm saying tight integration with all the SAP applications. Okay, so that is what this side projects, and we have the connectivity management to connect to most of the external systems that are already available, right? So this is a very high level architecture and the strategy of SAP, where it is placing SAP Data Intelligence and what it wants to do with SAP Data Intelligence. I do not want the customers to face problems when they are connecting into SAP applications. Yes, we have all the required integration mechanisms to connect to any SAP applications here. Okay. For non-SAP, what is the strategy? Yes, we have all the out-of-the-box connectors to connect to any external systems that are already available. Done. Okay, only connection is not my only criteria. I want to build a model. I want to do a cleansing. I want to build a proper governance mechanism in place. So what is it? Yes, data intelligence provides you the capability to ingest the data from the sources that have been mentioned, and then enables you to prepare a proper governance model, enables you to prepare a proper machine learning model, and then enables you to push it to the required third-party sources or internal SAP systems like SAP Analytics Cloud, where it can be projected as a report to the business management people. Okay, so this is the overall end-to-end data integration and processing mechanism, and this is what the strategy of SAP is: one solution, connect anywhere, do whatever you want. Like, as simple as such, right? So now, building agile data-driven process. Now, we have the approach by hand mechanism, and then we have the data pipelining mechanism. So for people who is not aware of what is a pipeline, probably, just to give an analogy, it is very similar to the data flow what you use in data services, right? You will have a lot of transformations, you will have the source, you will have the target, you will be connecting it, and then so one entire flow you will be creating it. So that is what the data pipeline is with data intelligence. Now, what is it that we are doing is we're just trying some custom operators, some workflow operators here, and then we are training some model, and then we are submitting the metrics that are going to come out of this model. Okay, now just don't worry about what the pipeline is doing. This is just for an example. Now, in case if you have to, let me give you an example. Guys, assume that if you have to write manually the scenario, what I'm going to tell you. Okay, so customers all already in ECC system. Okay, and they have an Oracle system. Okay, so what the customer's requirement is, say for example, I want to predict what would be the price of a product if it has been sold in a particular region. Okay, so now you have to get the data from these two systems, because these two systems are having the required data. Right now, what I will do, I have to build, first I have to do a data cleansing, right? So I do not want to have a bad data. Now, once the data cleansing is right, I have to extract this data, and then once extraction is done, then I have to build a model. Okay, train the model, and then push it to, say for example, SAC, so that if a user is here and if they are able to view the report, they will be able to see, okay, so this is what the model is predicting for this particular Lenovo laptop. This is what the price will be if I sell it in, say for example, South Africa region. Okay, now if you have to do this by code, is what has been given in this diagram. Okay, so this is the agile data driven approach, wherein SAP Data Intelligence provides you with the equipped operators, where it is a very simple and easy to use operators. You just drag and drop onto your interface, your operator is ready. Okay, so it's as easy as it is. Probably you will be able to, we have an exhaustive list of operators, like more than 25 plus operators, which we will be showing it on third day. And you will see how easy it is, how SAP has made your life easier. Instead of writing everything manually, just simple drag and drop. Now, if I have to say, for example, we have a flow to show you how to replicate the data from ECC system to SAP HANA. Now, with the required configurations in place, with the required operators, it is very easy. Just if with everything in place, within 10 minutes your pipeline will be up and running. Within 10 minutes, I'm saying within 10 minutes, if your configurations, everything is right, within 10 minutes your pipeline is up and running, will be able to replicate the data. That is how sophisticated it is. That is how easy to use. Now, one of the most important feature of SAP Data Intelligence, where none of them will mention, is it's very easy to use, guys. It's very easy to use. It's probably, if I have to give a comparison, why Apple has become a very big hit, because it provided the required easy to use interface for the users. It's on a similar line. It provides a very easy to use interface. When I log into the data intelligence tenant, and when I go through the metadata catalog feature and all those stuff, you will understand how easy SAP has made life easier to people. Right. So this is what it is. So we also have predefined machine learning services which are already available within SAP Data Intelligence, and you can take advantage of those predefined machine learning services. Say, for example, we have image classifications, image feature extraction, similarity scoring. So these are all some of the machine learning algorithms which are already provided to you by SAP. Okay, say for example, you want to identify something out of a picture. You take a car, just to give you a real-time example. Okay, so see the examples, whatever I'm going to give you, right? So it's a real-time example, and we have really faced it with a customer. So there is a customer, and there is a real-time example which we will cover in detail in the fourth day also. But to make you understand much better, there was a customer and there was an image classification algorithm which has to be implemented. So someone has to take a photo of a car. Okay, they have to take a photo of the car, and the system has to automatically identify what type of car it is, and then it has to convey to the user, okay, now based on the photo that you had taken, now I'm going to take the photo of the, first I'm going to take the photo of a full car, then I'm going to take the photo of the engine, I will take the photo of the tires. Now based on these, right, based on these photos, the system will have to automatically identify how much this car will be sold to if it's a second-hand car. Right now, I'm having a car which has been run for 10 years, 10,000 kilometers. Now, based on the photo, it has to identify this is what the price of the car will be. Okay, so these kind of algorithms are already available, which you can make use of it. You can avoid wasting time to create these algorithms from scratch. So SAP DI also provides you these kind of facilities. Okay, so now let me quickly go to the value services of SAP Data Intelligence. So I'm not going to spend much of time here because I have already explained you all these concepts. So extract value from distributed data, discover and connect. I have already talked to you about the connection mechanism. Refine and reuse. I have already told you about the predefined algorithms which are already available. Governance and compliance, yes, which we'll be seeing it tomorrow, how metadata will be able to set a proper data governance in SAP Data Intelligence, and data orchestration and execution, how we are going to build a pipeline connecting to various sources, and then say for example replication of data to a target database. We'll be covering all those steps, and on top of it we will be embracing open source technology. Okay, so we will be embracing open source technology, and we support R, Python, TensorFlow, etc. And basically data DI is based on Kubernetes and Docker, where you have to deploy it on the certain Kubernetes versions, and then it will start working. So this is actually a different breed altogether. I would really say, when you I myself from SAP, I found a little bit hard because this is a new breed altogether. So you probably a good understanding of the open source technology also will be very, very, very helpful for you, because if you know Python, you will be able to create your own custom operators, right? So right now, as a source database. Say for example, we have database X. We support database X as a source database, but as a target database, database X is not supported. It is only supported as a source. So what should be done in such a cases where I have a requirement? I have to push data from database X to database. I have to push the data from, say for example, Microsoft SQL Server to database X, which is not supported as a target. Right? So in those cases, you can take advantage of Python, you can build your own custom operators, and then you can push the data to database X. That is how flexible is SAP Data Intelligence. It doesn't have any restriction. It doesn't stop you from creating anything, right? So that is why it is also telling data scientists to bring their own models. You don't have to build models from scratch. You can consume your own models. It has a good tight integration with Jupyter models, right? So we have the foundation. So these are all normal slides for AI and other stuff, which I will ignore it. Okay, guys. So coming to SAP DI architecture, the high level diagram. So what is it that we have here? Okay, you see something on the left hand side, Docker registry and customer and SAP, right? So I will tell you about all those steps. And we have pipeline modeler, we have metadata explorer, we have machine learning tooling. So pipeline modeler to build the pipelines, metadata explorer for managing your metadata management activities, for machine learning to build models and train models, and system management for all the administration activities. And we have the connected system. So this is a high level architecture. Now we'll just go a little bit in depth. Okay, just a little bit in depth, but not to bombard you with the architecture details, so that you will I'll just make life easy for you. Once we start with the next session, right, Dockers and Kubernetes, you will have a very good understanding of what is a Docker container, what is a Kubernetes, and why it is in place, what is the advantage, how SAP Data Intelligence has embraced these technologies, how it is working. Okay, now, yeah. So I'll directly go to the SAP Data Intelligence component section, right? So the first one is, as I had told you before, what was the important problem that we are going to address is identifying the exact requirement, or identifying the exact data. If I have multiple data sources, it doesn't mean that I have to get the data from all the data sources. Okay, so identifying the appropriate data and the data sources is our first step. Now, what is the second step is that SAP DI Metadata Explorer. This is the second important component. So, guys, I forgot to tell you one thing in the architecture, right? So, yeah, we had a discussion and then we just left it. So, just quickly take 1 or 2 minutes. Now, we have data governance, we have metadata, under data governance, we have metadata management, we have data preparation, we have access governance. In a similar fashion, for data integration architecture, we have something. For pipelines, we are having a lot of stuff. Okay, now what do these separate boxes indicate? Okay, when we say components, okay, component will give you a different explanation. It means something. Component is different, but how I would term it is, these are all individual images on their own. These are all individual Docker images on their own. Okay, so what does that mean when I say these are all individual Docker images on their own? Now, I will probably give you an example. Okay, so in SAP Data Services, okay, so if my central management repository is down, will I be able to do anything? Will I be able to publish it? Will I be able to get the data from there? Will I be able to do some operations on it? No, right?
No.
Why? Can anyone tell me why?
It's all one, right? It's not
Sorry?
separate. It's all one, right? It's
Absolutely, absolutely. You're right, Murali. So that is what we call it as a monolithic architecture, right? Correct me if I'm wrong. It's a monolithic architecture where there is a heavy dependency. But here, if metadata management is not working, if I'm not able to use my metadata management also, it is not at all a problem for me. As long as my pipeline modeler is working, I'm happy. Metadata management is not working, it is still fine, because these are all individual images. They are not dependent on each other. So if I work, then only you have to work. No, I don't work, it is still fine. You can carry on with your work. So one example is, assume that metadata management is not at all working, but still I can use my connection management to establish a proper connection, I can upload, the models, whatever I have, or build models on the existing connection and then push it to SAC or some other third-party system, even if my metadata management is not working. Later on, you can scrutinize why metadata management is failing. You can analyze the pod. We have something called as a pod concept, which I will tell it to you. So you can analyze the pod, you can analyze the logs, and then you can see why it is failing, and then probably if you are able to rectify, you can rectify, or else you can raise an SAP incident. As of now, yes.
So just to add a few concepts here. So as Venkat rightly explained, these are all deployed separately in the same Kubernetes cluster, right? They're all deployed in their own pods. Pods is a concept which we will come to now. But just in case, if your one instance of, one of these modules that you see in front of you in the slides goes wrong, what you can also do is you can go into system administration and start up a brand new instance, right? So the details of how to do it, and this we will cover the system administration section on probably day 3 or day 4, right? But the bottom line is, all of these communicate, these modules are always in connection with each other, right? So if I bring in a file in Azure Data Lake connected in DI, then I want to profile it in data preparation, then I want to probably consume it in ML. So how do they talk? If you have deployed it separately, how do they talk? So one of the things which is not mentioned here because it's a technical level detail, but how it happens here, it is based on the NATS messaging system, NATS messaging. So again, it's an open source messaging system. It's a big middleware. Again, it is written in Go. As you know, complete data intelligence has been written in Go from scratch, right? It uses NATS messaging to talk between all of the modules that you see here, from the lineage part to the modeler, to the trace of a modeler, to the metadata sheet that you see once you profile a metadata, right? So all those things, the messages are done through NATS system. So why we are highlighting this importance is because it is important to understand how they function in order to do the debugging properly. Because there have been, we have encountered cases when the modeler is bugs or modeler errors which we see are not descriptive enough. We might want to go in one level deeper. One level deeper is a trace. You can enable deep level tracing, which we will show in the modeler. But again, if you're still not able to find the issue, the other thing would be to go at the pod level where each of these modules are deployed, and then analyze the pod logs, right? We can even analyze the pod logs. Probably we might be able to show you those as well. So it will all happen through CLI of Kubernetes, which also we would be able to tell you a lot about. So it is important to understand the architecture to analyze and debug really efficiently tomorrow, which is why we are trying to stress the concepts and the architecture part and how you can start the debugging, which we will anyways cover in depth. But I just wanted to highlight how this relates to what we'll be doing later. Over to you, Venkat.
Thanks, Ganesh.
So is that mean that I think this brings the flexibility, right? If that some components are not really working, or if there are any such features that we want to enable to a particular component, we should be able to upgrade or probably like add on to those features alone to that particular services, right? Not really like you don't need to disturbing the whole processes, right? Like
exactly. Yeah. There is also a way to create custom policies.
Yeah.
For example, if you want myself to only see the metadata, but I should not able to add anything to any of the connections, that also is possible. There you might be you might have a requirement that these people, they can connect with metadata, sure. They can pull from metadata, sure, but they shouldn't be able to do anything else, right? That is upload manually. They can only do through operators. That also can be possible. So all these concepts come under policy management. Again, under system administration, we will cover these as well in day 4.
Perfect. Yeah.
Okay. Yeah, sure.
So, I mean, Murali, to give a live example, right? So, what we do at home, right? So, suppose if you have to check whether your internet connection is working or not, sometimes we go to www.google.com and check, yeah, Google is working, so my internet is working, right? So, in the same fashion, say for example, if your pipeline modeler is not working, okay, let me go to the connection management tile and check whether it is working or not. Yeah, obviously, it will work because that is totally independent. It's an independent image, right?
Yeah.
So sometimes what will happen is, though these are independent images, some few of the features, few of the things, they would be grouped together and they will be put inside a same pod, right? So images which are very small, say for example, system management, we have the tenant management, monitoring. These are all probably some small images. They'll be clubbed together and they'll be put inside a single pod, right? So if that pod fails, then probably your monitoring and both tenant management will not work, because the entire pod has failed. But inside that pod we have 2 or 3 images which are residing, which are catering to monitoring or some other repository management or policy management. So obviously, if your entire pod fails, all the images will also go. But the best part about Kubernetes is it is self-healing. In case if it is something with respect to the environment, then it will automatically spin up on the upcoming thing. Okay, so this is what it is. So we have the Metadata Explorer, we have the data discovery, we have the catalog feature, and we have the lineage tracking. Now, can someone explain me? People have worked in data services, people have worked in information steward. With respect to data services, to just analyze what kind of data is available in the system, you are connecting to multiple data sources, and then you are extracting the data, and then you're putting it in the data services repository. And then you're discovering what data is there, which data has to be, which data is required for me, which data is not required. Correct? Now, how different is the Metadata Explorer of SAP Data Intelligence is, the first step, it is very similar to data services. Okay. You establish a connection to the data sources. Okay. You have 5 data sources. You establish the connection. You create a connection to SAP HANA. You create a connection to Microsoft SQL Server, whatever database. You create a connection and keep it ready. Now, in the Metadata Explorer, there is an option called as Browse Connections. Okay, I need everyone to understand this feature very carefully. What we can do from data intelligence is, we will be able to browse the data. Okay, we will be able to browse the data that is available in the source databases without extracting the data, without actually bringing in the data to the system. Right, so this is one of the most important feature which not many people will know, but this is exactly one of the important feature of SAP Data Intelligence Metadata Explorer. That is, you do a data discovery without actually bringing in the data. You do it at the source system level itself. So you save the time of extracting the data and then putting it and then doing a discovery on top of it. You save the repository space, you save the database space. Say for example, if you have to do a data discovery of 500 GB of data, first you have to extract, analyze 500 GB of data and then cleanse the data and then put it. No, here it doesn't work like that. You do a data discovery by creating a connection to the source system, analyze the data at the source system itself, and whichever is data that is there, you just profile the data and then you just bring it back. This is the most important, or one of the best feature which I really like with respect to Metadata Explorer is the data discovery feature, right? You can explore the data assets across the connected landscape, and you can use functionalities like discovery, preview, and profiling, which I will explain it to you in detail. Okay, so this is the first feature.
We are profiling and browsing through the connections, right? What we can do is we can start to, in order to join, we need not do it in pipeline. There is another way. I mean, you can do it in data preparation. The actual joining will happen in data preparation, right? Which also we will cover, where you drag and drop and select the columns, you transform the columns. So data prep is meant for business users, but we can use them as well, right? So this is the step of the joining, of the exploration and joining, right? So there are actually, let me start from the beginning, right? So once you have explored your data, right, what you would want to do is that, probably let's take an example that each system has, I don't know, like 200 GB of data, right? And you would, want to join a few tables from each of these sources, and finally create, one big CSV in a CSV file, and then you want to give it to a downward system. another SQL or a data warehouse, etc. Right? So the first step would be that we come to Metadata Explorer, we see the content, we see the structure, we see the types of the columns we are dealing with, right? We see whether which columns we want to select, right? So based upon our analysis, based upon all the discussions we have with the required stakeholders, we finalize the set of columns from here, right? And what data types they represent. The second step would be we take this information and we go and then we build a pipeline, right? Now, how will you build a pipeline? So that depends upon what source systems you have. If it's an ABAP based system of a suite on HANA, whether it's ECC, whether it's S4, it depends upon which of the systems you use. The operators shall differ. For example, with older versions of SAP, we have to go with SLT. If it's an S4 1909, there is some other operator. There is a table reader operator, right? So it completely depends upon which version you have. So the second step would be pipeline design. After we have designed the pipeline, we can start with a basic initial load, right? Probably, 1,000 rows, or if you have SLT, we can configure portions, right? So the second step would be the pipelines. After you have built the pipelines, you have tested the pipelines on a basic initial load or 1,000 rows load, right? Then what you have to do is you go to your Metadata Explorer, take these files, and as Venkat explained previously, there is a version, a subset of agile data preparation within DI, which we call as data preparation. There you can do a decent level of transformation, the concatenation, the joining, deletion, renaming, replacing. For example, you want to replace null values from one column, you can do that with simple SQL like syntax. It's not any special language, it's a basic SQL like syntax. And then what you would do is, once you have that, then you can output that information to another file, right? So now what you have done, you have begun the exploration, designed the pipeline, and you have one sample export. And the next thing would be that you run it for the entire data. For that, you can start scheduling the pipelines, or you can also go ahead and do advanced level of joins, which you can also do in data preparation, inner join, outer join, if you want to change the data that you are getting, right? So essentially it's
that means you are saying that if I have the one above function as my input, so it has some nested structure, okay? So that generally we convert to flat table structure after our extraction. So that thing also done in this preparation stage, right? In case of DI.
Yeah. So the flat structure can be created by the modeler itself. It will start bringing in the data immediately, right? But the second step would be, where do you want to push it? Probably you don't want to bring it into the persistence layer. You may want to immediately push it to another system, right? So again, there are a set of operators we want to push it outside. But if you want to bring it into DI and you use data preparation, then this is the method that you would have to go through. But the important point would be that in order to understand the structure, understand the spread of data values, that also profiling would show you whether X column has more nulls, what is the most unique value. There are various parameters which the profiling would tell you. But what it will help you is that without going into the data, without firing any query, without writing any Python code, you can understand the structure, number of columns, spread of the data values, and then you can immediately jump into the combination of the files, right? You can do that as well.
Think about like this. So you have receiving your file from the vendor or any new data set from the vendor, right? So business wanted to analyze, or like they want to know about the data set before even they bring the data into any of the into the platform, right? So they want to know the quality of the data. They want to understand more insight about the data, right? Like how many, what are the type of the data that we want to bring it in. Probably it could be bringing like more data types and all those things into the system. And so before they do the analysis, before they bring the data into the platform, if they want to do the further analysis, they would go to the Metadata Explorer and look at that, and then they can define the requirement, or they can define the data sets what they are looking into see, and all the things like that, right? And then think about this one other point, which correct me, Venkat or Ganesh. So this Metadata Explorer, there is advantages there. So basically, is like in data services, when you bring the data, like let's say that 200 meg data we have, or 200 GB data we have. So you have to bring it and you have to store that in our data services, right? Yes. Whereas here, it would be more of like the data would still reside in the source systems, or wherever it could be. It could be the files, or it could be like wherever it is. We are not transforming the data. We are not bringing the data anywhere. Just that the rules or the metadata, that just extractions of that, it will be there. Just more of that, just it brings that and it looks at it and it give you the view, and based on that you can define your requirement, because it's going to give you more insight about the data, and then you can decide from that point what you want to bring it to the system, or do we really need to bring it to the system. So all those things you can make it from there. So that's how you should look at this, right? This is nothing before the step one process. Not even you are not even building anything at this point. You're just like understanding the data. So that's what you're doing in the data discovery space, and this Metadata Explorer is going to give you that opportunity to to kind of explore that.
Right. And another trivia here is that the profiling capabilities of metadata is completely handled by a HANA instance. So SAP HANA instance is bundled with DI, right? Whether it's cloud, whether it's on-premise, doesn't matter. It's always there. And it has a lot of responsibilities, from auditing, security, and also handling the profiling part of metadata. This is managed by HANA in the background.
Yes, actually, not many of people knows this, but actually behind the scenes, HANA is there, and once the installation is done, you will be able to see the HANA instance actually running inside a pod. And there is also a way to connect your HANA instance, which is getting deployed along with the data intelligence.
Right. And also, right, once you have installed everything, right, there are, two levels of people. So one would be the tenant administrator. In the system tenant, right, we will be going through all of this, but as it has come up, I would like to point it out. So, and other would be the default tenant, where, normal citizen developers or, other people use it. So once if you're a cluster admin, right, there is a license section where you can go and see, whether the HANA is up, what is the license, what is the hardware key. So you can see all those details as well. And the Vora functionality, again, it runs on top of HANA pod, HANA instance as well.
So Prince, I think this is more of you looking at the data beforehand. There is nothing linked with your pipeline or the processes what we are building at this point. You just that you looking at the data beforehand, and define your approach, or maybe you can probably like you can able to create your requirement from that point, and so and you can build upon. So that's a data, that's a flexibility, that's are the features that you have it in a data intelligence. So that's all it is in short. So in today's world, you may not able to do that, or probably you might be using other tools and beforehand, and then you use the data services, because you would be seeing that in a preview and things like that in data services, but you would not be able to see the entire data set, right? This gives additional profiling features, and it brings like additional insight about your source data than what you really see that, right, in data services preview options, because that is just more of like clumps of it you will be seeing it, or you can limit it and you can see it. You will not be able to see the entire data set. And plus you need to bring that into your repository, and plus your the data store where you are, whatever the target systems you are in the staging area, you are defining it, right? Whereas here you don't need to do anything. It's just still in the, it's in the source. That's the advantage what you are seeing in the Metadata Explorer.
Okay. Thank you.
Yes. Prince, I mean, you don't even have to use this metadata. It is just one of the functionality. Even without using this metadata, right, I can directly create a connection and then consume it in the pipeline model. But metadata gives you the flexibility, right, to actually preview the data even before consuming it in the pipeline. and then you can preview it, you can cleanse it, you can do, there are a lot of data preparation enrichments that are available within the metadata management capabilities. Okay, once say for example, we take, your SAP ECC database, and then you are you are doing a data preview of a lot of other tables, and then you're telling, no, this is not required. Fine. You have previewed a certain set of data, and then, okay, now on this data, what the best benefit of metadata is, once you start profiling this data, right? You have to start profiling this data to get the actual insights of the data that you are previewing. Now, the first step is data discovery. Okay, fine. Connection is done. I'm previewing the data. I'm happy with this data. I'm going to consume this data. Now, what is the next step? Is profiling. Okay, profiling will give you additional insights. Even though you think that this data set might be good, based on the insights what metadata management is going to provide you, you will even tend to think, oh yeah, oh, this data is missing. Say for example, you have hundreds and thousands of rows. Okay, profiling will give you, was 45% of your data is null in this particular column, which you might not even be aware of. So based on those insights, you can do a data preparation on the data set that you have finalized. You can cleanse all the null data. Probably you can replace it, or you can leave it as a blank, or you can do something else. You can concatenate. So all those data preparations, and then you can use the cleansed data set in the pipeline if you have to consume that particular data. So this is the facility. Data discovery is just the first step. The preview is just the first step. The profiling is the next immediate step. So what I'm trying to tell you is, these are all the additional flexibility data intelligence is offering you. So you can, how you are using data services, the same fashion you can also use data intelligence. Just use pipeline, extract the data using the connection management, and then do whatever you want. That is also there. But the main differentiator is the metadata management, where you will be able to actually do a preview of the data, and then based on the preview of the data, you can cleanse the data based on the insights that will be provided by metadata management, and you can consume the proper data in your pipeline. So these things we will see it in tomorrow's session in detail, how the profiling works, how the data discovery works, how the publication works. So, okay, so these things we will see it in detail in tomorrow's hands-on session. This is one of the common questions in which I receive from a lot of people, right? What is the difference between data services and data intelligence? What is the difference between information steward and data intelligence? Is data intelligence going to replace information steward? No. So I will ask you a question, okay? So now what you do in information steward, you define Metapedia, you define rules. Will you be able to cleanse the data in information steward? So what is happening here? So what is happening here? So this is a traditional method, right? Information steward has been there for probably around 15-20 years, 2008 if I'm not wrong, correct? So what is happening here? So just for cleansing the data, I have to consume data services, correct? Now, for a customer who wants their architecture to be simplified, having information steward as one solution for cleansing the data, having data services as another solutions to perform the cleansing of the data, so will that not add complexity to their architecture? And from a licensing perspective, they have to license information steward separately. They have to license data services separately, correct? So this will add additional burden on their bill of materials, correct?
Yep.
Now,
right.
So this is one problem. Now, the next problem is you cannot compare the features that are provided by information steward and the features that are provided by data intelligence metadata management, because metadata management provides to a certain extent data cleansing techniques, data preparation. We can do some enrichments, but it is not as robust as what is available in information steward. Okay, though in the latest version, data intelligence provides an option for you to import the rules that you have created in information steward, but still at this point in time, it will definitely not replace information steward, because customers who are already using information steward, number one, they have to leverage their existing investment. How I can leverage the Metapedia or the business glossaries and the rules that I've already created within information steward, how can I put it in data intelligence so that I have a very simplified architecture? Okay, so this is one mechanism. Now, this is what DI provides an option to import the Metapedia and rules as of now that we had already created in information steward. So this is how you can leverage your existing investment that you had already put up in these systems. Okay, but when it comes to robust capabilities of complex rules assignments and all those stuff, still information steward hands down, it will be the winner. Okay, so depending on your use case, you have to choose the solution wisely. If the customer's main criteria is about rule definition, complex rules building, and then it's mainly like focuses around data quality, probably we would, as a trusted advisor, we can ask them to go for information steward, build all the complex rules that they want. And in the meantime, if the customers are not so much worried about the full-fledged capability mechanism what information steward is providing, but they want a certain or minimal amount of data enrichments or data preparations or certain minimal amount of data cleansing techniques, I will show you all the features tomorrow. What are all the data cleansing techniques? What are all the data preparations that you can do? If customers are satisfied with that, then they can go for data intelligence so that they will have a less simplified architecture rather than increasing their complexity by adding IS and DS. Got my point, right? Even everyone is foreseeing in that direction only what is going to happen. Everything is right. But as of today, right, when I will try to show you a demo, what is going to happen is, even when you try to import the rules within data intelligence, you will not be able to edit it. There is no edit option that has been provided to you. But SAP is coming up with it. SAP has already told that we will be coming up with the edit option, but later, in a later release, not immediate release. As of today, you can only import the rules. So this is just a baby step, Murali, to be very frank. Okay, so it's still at its infancy stage. I am sure it will develop, it will explode it into much bigger version, but we don't know when, we don't know where, but we are prepared. We have also interacted with a lot of partners and other things. The one thing which is we cannot rely on is, see, SAP's strategy, right? So yes, as you told, they are heavily investing in the space like editing of IS rules, and sooner they will also come up with pipelines so that if something fails, it will automatically recorrect itself and then probably put it in DI, or you might have a capability to put it back to IS so that we can consume it in both the hybrid world. See, these are all some of the strategies, customers' expectations that we are all talking about. But ultimately, it is up to the product managers who are there to define the strategy, what is going to come in the upcoming versions. As we speak, right, it is already happening, and the development is also in a fast pace because they wanted to position this as a one-stop solution because no other competitors have this. To trust me, I see. I really get into this market research analysis and do all those stuff. Okay, so I get involved in all the aspects of data intelligence. So trust me, no one in the market, as I told before, has one solution which can cater to all these stuffs. Because see, I'll tell you very frankly, me and Ganesh, right? So the partner company that which we are working for also, we are positioning DI aggressively to our customers as well. Yeah. Right. So only TI. So we also get involved in other cloud solutions. So see, typically we are also into a lot of solutions. We are also into solution delivery apart from other solutions, but data intelligence is one that we as a partner company, we are positioning it to other customers very aggressively. Right. And that's why we also get a lot of requirements with respect to installation, with respect to enablement and all those stuff, because they also understood the importance of DI, where it is going to go. See, it is like, instead of getting in pace, so after 1 or 2 years, assume that this product is getting matured. Instead of at that stage, we get enabled from now itself so that we get sophisticated at that stage and we'll be ready in the market. So that is the funda here, right? So we will see each of these activities like, discovery and profiling, search, data lineage, which is one of the most important features, which all of you guys must be knowing. I don't have to explain what is a data lineage. It is available in the cloud version, but it is not available in the on-premise version. I will even try to show you that in case if I get the hand of my partner system. We have the data preparation techniques, and we have the tagging features, policies, business rules. So this is what the metadata management is all about. So this is what the data preparation would look like. As Ganesh had also explained, like after you preview the data, and then if you have to bring in the data, you just have to profile the data to get some insights, and you want to do some data enrichments or data preparations on top of it. So you will be able to do, it says, for example, some of the features like replace, duplicate, order, sort, concatenate, something like this, you will be able to do. So in tomorrow's hands-on session, what data sets that I had prepared is, I had prepared 2 kinds of data sets. It's like end-to-end flow, wherein you will be doing a data preparation activity. You'll be joining those data sets, and then the output will be stored in the Azure storage account, and how we are going to consume that. Just to give you, a heads up on what a data preparation is, how the screen might look like. So this is what it is. Some of the features in data preparation.
All right, let's test your knowledge. Here's a question for you. Which of the following is not a component of SAP Data Intelligence? Option A, data provisioning. Option B, data cataloging. Option C, data preparation. Option D, data replication. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, ready to dive into the world of managing supplies? Our SAP Data Intelligence course is here to guide you through. You can tackle it at your own pace right here on our platform. In this course, you'll explore SAP Data Intelligence, which is like a toolkit for planning things, ensuring we have enough products and getting them where they need to be. From the basics to advanced strategies, we've got you covered. Our experts crafted this course with their wealth of experience. Your instructors are seasoned pros, dedicated to helping you learn and addressing any questions you may have. And guess what? Our students rave about how helpful this course is. Folks just like you have found it incredibly valuable. And the best part, it's super affordable, so you won't have to break the bank to learn. Ready to become an SAP Data Intelligence Pro? Sign up on our page now. For more details, visit ZaranTech's website.
So, okay, now we are getting into the second portion, that is Dockers, where I'll explain you what is a Docker, what is an image, how to build an image, everything. After certain explanation, I will just walk you through, how to build a Docker container, what is it exactly, and I will also show you at the end of the demo, one installation that we already have. How does it look like in a data intelligence installation? So what are all the pods that are available? How, something like that, I'll just show it to you, so that in case tomorrow, if you have to, see, this will be a good knowledge session for you, right? What is a Docker? So Docker was essentially a need to come out of a problem that I'm going to tell you now. Okay. Now, I will give you a scenario. Imagine yourself as a developer. Okay, you're developing some application. So probably you're creating a website using HTML applications, PHP, or whatever it is, whatever the programming languages. The first thing that you do is write some code and test that code, right? So the kind of environment that you would be putting this code is something that we will have a look into it now, right? So we have okay, so we have a developer here, and then we have this box, and then we will see what it is, right? So as a developer, what is the first thing that you do, right? So you are creating an application now. What is the environment? The first thing that I would need is operating system, correct? I need an operating system. Now, on top of operating system, what is it that I need? I need a programming language or a development language software like HTML or Visual Studio Code or PHP or whatever it is, right? So to develop my application. Now, apart from this, we would also have to take into consideration the third-party libraries that we would be including in our code. Let's say, for example, if you have a PHP system or probably connect to a database, right? Like SQL Server or MySQL, correct? So this is an application layer, and this is going to be the DB layer, right? So this has to talk. So for that, we would need some binaries which allow the application layer to talk to the database layer. Now we need to, I'll just put in the libraries here. Okay. So these are all the three important items as a developer that I would require. Now, what is a common issue that we face, right? Now the development has, now assume that you have completed the development. Now the next step is testing, correct? So the next in the process is testing. Now, testing, what you will do in the normal traditional way, what we will do, yes, the developer is complete, now you can go ahead and test. So the developer will also try to mimic the same environment. He will also have the same OS, he will also have the same programming language, environment, and he will also having the same kind of libraries, right? But guys, you would have been hearing this multiple times, n number of times, being a developer. Boss, this is working in my system. This is definitely. How many of you have experienced this? I mean, people who actually came from QA background or development background, right? In the traditional waterfall model, if you are following that, how many of you has actually experienced that? It is working in my system. It is definitely not working in my system. So in order to eliminate all these system, right? That's why we have the Docker containers. So how Docker containers will eliminate this particular challenge that it is working in my system, it is not working in my system. How can it provide a seamless way or provide a seamless environment for both the developers and the testers to test the same application in the same kind of environment so that they don't have fault. Even the testers had developed, the tester was also using the same OS, same probably environment like what the developers were using, but there could be minor changes, like some libraries would have been missing, some libraries developer would have added which he would have forgotten to include and or inform tester something, right? So now what is the solution? Okay, before Docker containers, what is the solution that people would immediately think about? Correct. So you might think about a virtual machine. Correct. In case, so what is the other option that people would think, okay, why don't we in this cloud world, right? Why don't I spin up a virtual machine, I develop an application and give the same virtual machine access to, the tester, right? So that is also a very pretty viable option. I do not say, that is not a wrong option. So now what is the problem that this again creates, right? So what is, say for example, what is the size of the VM that a developer is going to give it to the tester, right? Say for example, if this is going to be a 32 GB RAM VM, now it should have some persistence. Say for example, this is have 100 GB HDD. Now I'm going to give the same VM to the tester. Yes, no problem. The tester can test, he can validate it. But do you think it is possible for each and every developer to have their own VMs? Right, so developer 1 might have used this VM, developer 2 might use another VM, developer 3 might use another VM. Do you think is that possible? No, absolutely that is not possible. If they have to test all the features of all the developers, then as a tester, okay, assume that I am a tester, I'll be end up having 100 VMs, more than 100 VMs. Okay, for each feature or for each application, I don't know which VM I have to test for whom. So this will create a lot of chaos. Right now, you got a clear understanding, right? Why we should not use VMs. This will definitely create a lot of problems. One from infra perspective, that is one from licensing point of view. That is, say for example, if this is going to cost you like $0.05 per hour, then imagine if you have 10 developers, 10 virtual machines, it will easily cost you $0.5 per hour. And then imagine how much it is going to cost you for a month, and how many VMs are going to be there, how it is going to be tested by the tester, how they are going to maintain it. So all these overhead facilities are, these are all some of the problems that when we use a VM. Okay, so this is also not a possible option now. So who is coming to the rescue now? So we have the containers to the rescue, right? So we have the containers to the rescue. Now what exactly a container means? The proper definition of a container is an entity which can contain all the software dependencies and be ported to another computer, like a plug and play device. It is like a packaged solution which can be ported to any other device, just like your USB drive. You just plug it to any device, it will work, right? So even it doesn't know who is a tester, it doesn't know who is a developer. You just plug and play, it will work. In a similar fashion, as an analogy, you can consider as USB, right? So you can bundle all the software dependencies and then give it as a container to the tester so that they will be able to test it in the same environment like how the developer has tested. Not even a single binary will be missed out. So this will eliminate the problem of it is working in my environment, it is not working in your environment, because here ultimately the tester would end up using the same environment what the developer is using. Okay, say for example, I have the developer here, and I have the OS, libraries, and I have the software, right? So what I will do is I'll create a wrapper, right? I'll create a wrapper around this. Container is like a wrapper, okay? So I will just, tell the tester or people whomsoever is testing, So this wrapper, which will basically contain all the required files for running the application successfully. So these wrappers will be delivered to the testers. Okay, so testers will then test in the wrapper. So this wrapper will consist of all the OS libraries and the software used by the developer. So the testers don't need to worry about the underneath platform, what has to be configured, what has to be used, what binaries has to be used, what software I have to install. No, those things are already eliminated. Everything here will be shared to the tester and it will be done. So, and one more advantage is tester, assume that this is a QA environment. We have OS, library, and software, right? So this is a wrapper. So after tester testing this wrapper, this container, if tester says that everything is looking good, the same image, what the tester, what he will do is the same wrapper he can also deploy it in the production, right? He can also deploy it in the production. So it doesn't also, you also don't need to worry about whether it is a development environment, whether it is a production environment, whether it is a QA environment. No, I wrap it, I give it to you, you test it in whichever environment you want. If you are happy, deploy the same container in the production environment also, right? So this is the main funda. Now I will, in the demo, probably I'll take some more time to explain, few of the stuffs, right? So in the demo, what we will do is, I will show you how to create a container from scratch. What do I mean by logging into the container, seeing what services that we can start, everything I will show you, okay? You don't have to worry about that. So Docker is a computer for a proper definition, right? If you require, a Docker is a computer program that helps people in wrapping, in creating a wrapper around the files of code, right? So that might include operating system files, libraries that we have already mentioned. So this is what it is. Now, unlike VMs where we told, right? So if you have a 32 GB RAM and 100 GB of space, so what is the, people will ask us, okay, container also, if you're wrapping your OS, if you're wrapping your libraries, if you're wrapping your software, everything you're wrapping, so containers also will be huge in size. Is it right? Can anyone tell me? See, what I told is developer will wrap the entire environment, correct? OS, if he's using Ubuntu, Fedora, whatever it is, or Windows, whatever it is, and library, software, I'm wrapping the entire thing, right? Correct, guys? I'm wrapping the entire thing and then I'm giving it to the tester. Now, when I wrap the entire thing along with the OS also, obviously Windows OS is of 7 GB or 8 GB or 10 GB in size, right? How can I give it to the tester? How will I transfer the files? How can I do it? Can anyone tell me why? Will it be possible? Please open up your mic, guys. So if I have to wrap up my my OS library software, it will also obviously say, for example, equivalent to 10 GB or 20 GB. I can easily go for a VM itself, right? I am saying it is portable like a USB. How is it portable? When you say something is of 10 GB or 20 GB in size, how is it portable? Can any one of you tell me? When I say OS, it is not the actual OS. It is only the required files that are necessary to run the OS. Let's say, for example, if you have an Ubuntu image, so Ubuntu operating system itself will be around 2 GB or 2.5 gigs. But when I create an Ubuntu container, you will see the file size as 85 MB, only 85 MB, if I'm not wrong, right? As of today, I think it was around 85 MB. So you can see already the difference. Ubuntu OS is 2 GB and this container is just 85 MB. How does it work is, for spinning up the container, it requires a minimum files, that minimum files will be there. Okay, what about the other files which are required by my application, which are provided by my operating system? Who will provide it? Right? How will this container know which kernel I have to use, or what is the process that I have to use? Okay, you have the minimum files to spin up an operating system, fine. But my application requires more. My application, if I have to run in this container, it requires more processing. It requires additional stuffs which can be provided only by your original operating system, which is of 2 GB or 2.5 GB. So how does this work? How does this funda work? Right. So for that, I will have to explain you a concept. Okay, so now this is one architecture which I would like to explain you how it works, right? So we take laptop as an example. Okay, our laptop, whatever we are using our laptop as an example. So laptop is the hardware, right? Everyone accepts. So my laptop is a hardware and an operating system is installed on my laptop. So we are done. The hardware is the laptop and operating system. I have a Windows or I have a Linux. So for easier understanding purpose, we have a Linux as an operating system. Now on top of it, I have the container engine installed. Okay, in my operating system, in my laptop, I will install container engine. So guys, when everyone talks about Docker containers, they think it is a technology. Okay, so one way they are right, one way they are wrong. Containerization is a technology, that is right, but Docker is a company name. Docker is a company name and Docker containers belong to Docker company. Okay, so you have also other competitors like Mios, if I'm not wrong. That is also one of the company which provides you containerized technology. So containers is a technology and Docker is a company which are using this. Okay, so I installed Docker. Okay, I installed my Docker, which is the container engine. I install it on my operating system. Now I will spin up a container here using my container engine. I will spin up an Ubuntu container. Okay, now we have the hardware set, we have the operating system set, we have the container engine set. Now what we would do is we would install containers. We would be running containers. Say for example, if my application that requires Ubuntu, I would deploy a Ubuntu container. If my application requires a Fedora OS, then I would deploy a Fedora OS container. Guys, you are already able to see the advantage here, right? On top of operating system, I can have multiple containers with multiple operating systems. One container for Ubuntu, one container for Fedora OS, and one container for any other flavor of operating system. But the base operating system is what I'm using. My hardware is my Lenovo laptop. My operating system is my base operating system is my Ubuntu, and I already have spinned up an Ubuntu container. I have already spinned up my Fedora container and one more other container, right? So I have 3 containers running. So to answer I have already answered the question how it is low in size, because it only has the required files to spin up the container for the particular OS. Now, so a container does not have a kernel. Okay, so this is one of the main understanding. So if you are creating an application which is using some of the operating system processes, how the container will able to cater to it if it is very small in size. A container does not have a kernel, so it shares, right? It shares the kernel with the operating system. Let me check whether my pen is working. So it shares, okay? So it shares with the operating system. It shares the kernel. Whenever it is required, it talks to the underlying operating system and then it gets the required processes and it serves your application. Now you got the point, right? How actually the container is working. So why it is low in size, and in case if it requires any other processes, where it has to reach to, it will reach to the underlying base operating system. It shares the processes with the base operating system and then provides it with your provides it to your application. So whenever it is required, it talks to the operating system and gets the thing. It shares. That is why it is very low in size. And whenever your application has a dependency on certain operating system processes also, you don't have to worry at all. So same laptop, I can have 3 different applications. I'm saying 3 different applications. Say for example, I have my e-commerce application running on Ubuntu. Yes, one container, I will deploy it, it will run properly. I have a booking, ticket booking application running on Windows. Yes, I can spin up a Windows container, I can do it. I have another application running on Fedora OS. Yes, I can do it. One single laptop can cater to all these 3 applications running on different OS. Right, so I don't have a clue about how Windows Docker works, because I really haven't worked with the Windows Dockers, but I have good experience with Linux Dockers, right? So here, assume that my core operating system is Linux. Now what will happen is, say my core operating system is Ubuntu. So here we have a Ubuntu container, Fedora OS container, and probably some other container, right? So since the underlying operating system is a Linux kernel only, these 3 containers, they don't worry about anything, right? So I'm not sure how it is the case with Windows Docker, because I have not really worked with the Windows Dockers. So probably they might, adopt the same mechanism. Probably I can get that information and get it to you. So this is what I wanted to explain you. And now you are able to understand, right, how different it is from a virtual machine. So virtual machine, you will have one more additional layer here, hypervisor layer, and then from there you will spin up the virtual machine. You will have guest OS, and then on top of it you have other applications. Correct? So this is the difference between a virtual machine and a container.
Yeah, we can see your footage screen, Venkat. But before we go there, just one point from my side. I'm sure all of you would have heard the name hypervisor, right? You have heard now something called containerization, and then there is something called virtual machines. So Venkat has already clarified, the differences between a virtual machine and a container. But how does hypervisor relate or differ with containers? I will tell you, because I'm sure we would have encountered the Hyper-V is the name of the hypervisor for Windows. So how that works is, so hypervisors are essentially of two types. One are, bare metal ones, which run directly on hardware. But the number two one, which all of us would have encountered one way or the other, is the hypervisor, which works on top of the operating system, right? So this is the most important part, that hypervisor work on the OS, Docker works on the kernel, right? But hypervisor, as you know, in your own laptop, for the more people, inclined toward Linux, you might have had two OSs on the same machine, right? One might have been Ubuntu, one might have been Windows, right? Or for those having Apple, they might have also have Windows, right? So this is only possible because you have an hypervisor. Hypervisor can support more than two operating systems, more than one essentially, right? But the Docker, it only sits on the top of the kernel, which is why it can do so many things, and which is why it, all this was born out of a need in the industry. It is not like somebody, essentially invented it. It's essentially a need which was born out of the the want of having immutable environments across systems, across servers, irrespective of hardware. So that was a need, and which is why we use Docker as the preferred deployment option rather than a hypervisor or a VM or others, right? So this is the classification where Docker differs and how we use it also. Yeah, but the Docker, it is built on one image. It can be only one image. It can be Ubuntu one. It can be, SUSE. You can make 100 copies. You can make 500 copies. So it supports only one OS. And after that, you can install whatever you want to install, any EXEs, any packages, any softwares, any SDKs, right? So all those you do after you specify the base image. There are a couple of things here. There is one thing that is about Dockers, right? The second thing that you're referring to is the management of containers, right? So these are two completely separate things. So right now we were just talking about the capabilities of Docker, capabilities of hypervisor, and capabilities of the VMs, right? And we came to a conclusion, with examples and understanding that in an immutable environment, for an immutable environment of applications of supporting libraries, the preferred way is Docker, right? But then naturally the problem comes, if you have one Docker, yeah, fine, that's okay. But what if you have more number of Dockers? What if you want to distribute jobs, or if you want to distribute it processing, if you want to get the results back from them, right? So when this part comes, right, when you are talking about a group of Dockers, that is when the management of containers comes. I would like to say it as a container, not a Docker, right? So once you have single container, that's fine. But when your number of containers increase, we need to have management, right? And that is what we call as container management, right? And this is also a term which we all know, that Kubernetes is one of the leading container management technologies out there. It was created by Google, right? Again, it was a need. You can do something good, but unless you can, do it something else at scale, it's a failure. So that is where Kubernetes comes in. Kubernetes is nothing but container management. If you want to organize, add, replace, deploy, manage, scale, networking. So Canico is the networking, part which we use within Kubernetes. So how do you network between 5 machines, between 500 machines, right? So that is where Kubernetes comes in to manage the containers. So there are many things, which Kubernetes does. For example, like health, managing the health of pods, of machines, replicating, balancing the load, allocating hardware resources, right? So, based upon the capabilities of Docker is where Kubernetes comes in and says, one Docker, it's fine. If you have thousands of Dockers or, tens, 50s of Dockers, I can help you manage them at scale, which is where container management and Kubernetes comes in. And as you know, we have been talking about scalability. This is how it has evolved, and this is why when we say DI is scalable, these are the concepts behind it. First concept is the container, which we will cover Docker in detail. Second step would be managing multiple containers, that is Kubernetes, over which DI is based. So Kubernetes is a container management platform, DI is a software, right? And that's how it's being managed. So this is the the entire history behind the same. So now what Venkat will be demoing is how do we create a container, how do we deploy it, how do we do all the basics of it, starting from the intro. I think intro is done. We will be jumping into the.
So after this Docker, we are going to cover Kubernetes in depth. Okay, so that you will understand how it is also there. You can connect the dots, and then you will have a clear end-to-end picture, right? So now, probably even after this intro, some people might be wondering, still they will not be very clear about what is the container. So for those people, probably this hands-on will be a solution for you. I know a few people will be able to get it, but few people, even considering myself, only when I see it in action, I'll be able to understand, rather than the explanation that we provide. Okay, so now I am inside a Ubuntu machine. Now consider this is your laptop and this is your Ubuntu machine that you have already installed. So what is the first thing that we do is probably I do a repository update, right? Sorry, I do a repository update. So apt get update is the Ubuntu command to update the repository that is available within the Ubuntu. So I'm using the sudo because I don't have the root username and password. So I'm just using the sudo. Now my repository has been updated. So what is the next thing that I have to give? I have to install the Docker, right? Now I have to install the Docker. So where will I install the Docker from? So I will install the Docker using the command sudo apt-get install docker.io, right? So as soon as I give sudo apt-get install docker.io, it is hitting my repository. Yes, Docker is there. So now shall I go ahead and download this? Done. My Docker will be installed. As easy as it is. You see how much time it took me to install Docker, right? Just one command, my Docker is installed. Okay. Now, what is the next step that we have to do? Let this Docker get installed. Now this will install all the packages required for the Docker software. Now once this is all set up, we can check whether the Docker is working by typing a command. Probably we can just check the version of what Docker has been installed on our machine. So in the interest of time, right? So I will also cover one more quick concept, Docker Hub, right? So you people have experience working with GitHub, right? So very similar to GitHub, we have a Docker Hub where you can, it's a central repository. You can push the images and also you can pull the images, right?
It's similar to GitHub, right?
Exactly, similar to GitHub. So you have a Docker Hub where I have created an account. I will show you. In this demo, I will show you how to push the images to the Docker Hub so that even other colleagues can pull the images from the Docker Hub from the repository that you have, put in. I have spinned up a virtual machine, and on top of virtual machine, I'm installing a Docker, right? So for people to make it easier to understand, just consider this as your laptop, and you have an Ubuntu machine installed, and you have the access to the CLI, right? So you have the command line access to your Ubuntu, and from the command line, what is it that you will be doing?
Okay.
Okay, so this is the Docker image and Docker is installed. So sudo docker version, let me check. Oh, sorry, sudo docker version. Okay, so we have the Docker version 1903 something. So just to check whether the Docker has been installed properly or not. right? So now what we do is we will just perform few Docker operations. Now what I will do is I will pull a Ubuntu image from the Docker central repository. So sudo docker pull Ubuntu. So guys, what is it I'm doing? So I have downloaded an Ubuntu image from the Docker Central repository, right? As soon as you install Docker, so Docker will have some public repositories which will be available for you to use, like Ubuntu image, Fedora OS image. A lot of images will be available. So by this command sudo docker pull Ubuntu, I have already pulled in the Ubuntu image. Okay. Now, how to see the images that I have pulled? Docker images. Sorry, sudo docker images, right? Let me clear the screen here. Okay, so we have the image, right? You are able to see the Ubuntu image, and we have some image ID and the size. Guys, can you look at the size? 72.9 MB, right? Like I told you, this is a proper Ubuntu image, so which is running on Ubuntu, which is nothing but your Ubuntu OS, but it is size only 72.9 MB. So this image will have only the required files that is necessary to run a basic. You can consider this as a mini OS. Your mini OS running inside your major OS, right? So which is only 72.9 MB. So, and now what we will do is we will run this image. Okay, when I run this image, it is nothing but I will automatically spin up the container. When you run the image, the container will spin up, right? So I will just say sudo docker run -it for interactive mode, and then the image name -d, and then the image name. Done. So something has come, my Docker image has run, and it is giving me some kind of ID. Now, what is this ID? So, and the parameter -d, it means that it will run as a background job until I explicitly stop it, and ID is interactive. So now, when you run the image, it will be a container. Okay, the image will be running inside a container. Now, how do you see the containers which are running? Sudo docker ps. Okay, so if you see, this is the container ID, so which is automatically populated, and I think this is trimmed. So this is the longer version of this thing, and this is the trimmed one. And we have the image name, and we have the container running. Okay, so now what is the next step that we have to do after running the container? Now, how do you stop a container? Very easy. You just have to do a sudo docker stop and then the container ID. So I'm not going to stop the image now. I'm not going to stop the container now, but in case if you have to stop the container, you just have to give this command sudo docker stop and the container ID. It will stop the container. Okay. Now there is also one more command, sudo docker ps-a. Now what is the difference between ps-a? So what is the difference between sudo docker ps and then docker ps-a? So -a will give you all the containers which have been running or which have been stopped also. But docker ps will only give you the containers which are running at that moment. Okay, that is the only difference. Now, we had been talking a lot about this image, and we had been talking a lot about this container. Can I log into the container now? I am an application developer, right? Consider this scenario. I'm an application developer. I have to develop an application on Ubuntu, and I have to wrap it, and then I have to give it to the tester. Now I have downloaded this Ubuntu image. I have to spin up the container. So what should I do from here onwards? How shall I develop my application on this environment? Or how shall I do some changes in this environment? And then I wrap it, and then I give it to the people. So we have to log in to the container. Okay, we have to log into the container. So what is the container? What is the command to log into the container? So sudo docker, it is exec execute, and then interactive mode, and then I just have to give the container ID here. So I just copy. I just copy and then I paste it, and then okay. So this is the command. It is not complete yet. So sudo docker execute interactive mode container ID, and then I have to give the bash, because bash shell for Ubuntu, it is the bash, and it will take me directly to the container. I am inside the container now, guys. You're able to see the difference. Root at my container ID, here it is admin123 at docker VM host. You're able to see the difference. I'm inside the container. I'm inside the Ubuntu. Now, if I do a ls-l, I'll be able to list the files that have come along with this Ubuntu image, right? Say, for example, I do a sudo command not found. Can anyone tell me why this is coming here? Till now, we are using sudo, but now sudo is not working. Why? We have come from our machine, and then we are logging into the Ubuntu container. We are inside that Ubuntu. Now, this Ubuntu does not have the required library, or this image does not have the required library to execute the sudo command. So this one is missing, right? So I told you, right, it only has the bare minimum libraries to spin up this entire container. So this is not available. Okay, now we have logged into the container, and then we will just do container repository update, apt get update. So I'm just updating. I'm just updating the repository that is inside my container. Okay. So now the repository has been obtained, and probably so we have a few commands to remove the images also. And let me say, I'll just give you also one example, mkdir, and then I'll just put it as TCS and ZaranTech, right? So I'm just creating this particular directory. If I do a ls-l, so I'm able to see the directory, whatever I had created here, correct? Now I am doing an exit command. I have come out of the container. I am doing a ls-l. See, nothing is there, right? So I don't have anything because I have created that directory inside that container. So it will be available only within that container. So in order to remove a container, what is the command that you have to use is sudo docker rm, and then your I have to get my container ID, right? So what is the process to get the container ID? Sudo docker ps, and this is my container ID. Yes, so sudo docker, and then rm is remove, and then I have to give the container ID 7742 or whatever it is. So I'm not going to remove the container now. I'll just keep it as this, right? So now I do a ls-l. I'm not able to view the directory, but if I log on to the container, I would still be able to see the directory that I had created. So what is the command for us to log on to the directory? So we have sudo exec -it, and then container name and bash. But I'm just reusing the history that Ubuntu shell maintains, and then I'm using that. So I'm again logging in ls-l. I'm able to see the directory because this is totally independent of whatever you had created outside or inside your machine. Okay, so this is totally, whatever you do here, it will stay within the container, and it will be totally independent of the outside host or the machine that you are already in. So now I will just show you how to create a Docker Hub account. Probably, I'll just take some. Just let me know once you're able to see my screen. I will just open the Docker Hub account here. I have not yet shared. Just give me a second. So now just an example, right? So we will just try to install an Apache server there, and then we will see whether it is working. We are able to access this Apache server from outside our host, right? So we'll just what we will do is I will just run, the container is already running. So I will just log on to the container. Okay, again, I'll just log on to the container. Now, what I have to do here is I have to say, this is just an example that how I have to create an Apache server, run the Apache server, which is accessible for the container. But it was going to be a development environment, probably in the Ubuntu space. You can have your own development environment and do all those necessary steps and then package it as a container, right? So this is the funda is going to be the same, right? Whatever I do, it's just the fundamentals, but it holds good for anything that you do within this container. Okay. So now I have already updated the repository also. So what I would do is I will just do apt get install Apache 2. Right. So it is installing my Apache server. So in the meantime, I will probably ask you guys a question. Okay, now I am installing some this in this container. Now what I do is I come out of this container. Okay, I come out of this container and then I come out of this container. I delete the container. Okay, I did something. I delete the container, but my image will still be there. If you do sudo docker images, my Ubuntu image will still be there. Now I'm again running the Ubuntu image. So when I run the image, it will again take me back to the container. So can anyone tell me if I do this way, will I be able to see the installed files, whatever I had given here? People get confused with image and people get confused with container, right? See, whatever I'm doing, it is inside a container. Whatever changes I'm doing, it is inside a container, right? Now I am not doing anything to the image which I have already pulled from the Docker repository. The image is lying idle, but I'm creating a container using that image. Whatever changes, it is only with respect to the container. Now, if I delete that container, right? If I delete this container, the container will be deleted, but the image will still be the same. But what is that image? That is nothing but the image that we have pulled from the repository, correct? It will still be idle. You got my point, right? Say it is like, you have all the raw materials ready to prepare the food. Okay. You prepare the food, but your raw materials are there. Say, for example, you have 3 to 4 raw materials you're cooking and then your food is ready. Now, whatever you're doing is with respect to the food, not the raw materials, correct? You add something, you do something, it is with respect to the food. Now, when you throw the food to the dustbin, what you have to do again? Again, you have to take out all the raw materials and prepare the same food, correct? The food will not be there because you've already thrown it to the dustbin. Now, but the raw materials still exist, correct? So that is the same case here. Whatever changes you do, that is with respect to only the container. The image is nothing but you have pulled it from the repository. It will still be in the same base image only. So if you want, you can try this out. Probably you can pull that image, you can create the container, you can go through this video again, you can pull the image, you can do some changes. Whatever I'm doing here, you can execute the same thing. You can remove the Docker container. I've shown you already the command, right? How to remove the Docker RM and then the container ID. You can remove the container. Now create another container. How do you create another container? You just run that image, right? Sudo docker run -interactive mode and then the image ID. Now another container will be spinned up. Just go inside that container and check whether whatever changes you have done is there or not. Obviously it will not be there, right? So now our Apache is installed. We will just have to check whether Apache 2, sorry, I think it's Apache 2. Let me check. Apache 2 status is not running, so we will just start the service. The server name directly global. So fine, I'll just start it off. Starting Apache, yeah. So now if I do a service Apache 2 status, yes, now it is running. So guys, remember, don't get confused, okay? So we are doing all these changes inside a container, not on the machine, right? So your laptop is different and the container installed in your laptop is different. Whatever we are doing is on the container. Like already I told you, right? We have created a directory, but we are not able to see it outside the container. When you exit the container, you will not be able to see it. It will automatically package it. Only when it is required, it will directly see. You will, as an end user, we will not be even knowing this. Murli. At the back end, they will be able to talk to the operating system, and then they will be able to get it.
Yeah.
Right. So now we have the Apache server started inside the container. So now what we will do here is probably we will just exit the container, right? Now, if I do a service Apache 2 status, it should show me the status of the Apache 2, right or wrong? I am out of container, so that's why it is not showing. And now we don't have any Apache server here. Okay, now for people who are wondering, okay, now if I have to take these changes, like Murali had told me, right? If I have to wrapper it and then I have to give it to other colleague, what is the process? We have to save the changes. We have to commit the changes, right? So for that, what I will do is I will do a sudo docker ps. Okay, now this is our container ID, correct? This is our container ID which is running where we had installed the Apache. Now what I will do here is I will do a sudo docker, I will do a commit, right? And then I will give the container ID here, right? And then I will give an image name, Venkat. Probably I'll just say 9890 / my Apache. I hope this should work. So I will tell you why I'm giving in this fashion, this image name. Let's see. No, you have to, no, you will not be able to do it to the base image. You have to put the base image and then you have to create a new image and then you can remove the older image. You know, if you don't need it, you can remove the older image, right? So it does not have any impact. See, why? Because there is a format for you to push it to the Docker Hub. There is a format, okay? Using that format only, you have to commit it to the new image name and then you have to push it to the Docker Hub and then they will be, other people will be able to take it. No, this is the image ID. This is the image ID. And probably this is the name where I want to, push the images to. So this is the repository. Either I want to push the images to, or this is the repository where I had pulled the images from. Right. So this is a Ubuntu image that we had pulled, and this is from the Ubuntu repository of Docker. Okay. Now, I do a I do a sudo docker ps. Okay. Now only one container is running. Can anyone tell me why? Only one container is running. So now what we had done is we had created an image out of it. That's it. We just have to create an image. Now how the Ubuntu image, right? Now when we have to log on to this Ubuntu, what we did, we just have to run this image, correct? Now when I run this image, then automatically, my container will be created, right? So just let me run this image and then I will just give my this image.
You have to give the new name, right? What are the new images?
Yeah, so this is the image. Okay, so I'm not able to copy. Let me check. Yeah. So now if I do a sudo docker ps, you see I'm able to see two containers, right? If I do a sudo docker execute command on this and then I log on to this container, I'm not going to do it now, but if I log on to the container, I will be able to see my Apache running because this is the container where, I had, this is the image which I had built saying that my Apache should be running, right? So if I'm able to do it, I'll be able to see the Apache that is installed inside that container. So this is how we package the solutions. Okay. Now, let me try to do this sudo docker. I'll just run it again, right? Probably so iPhone in fact mode. Yeah, what? Okay, so I have to map in order for me to access this Apache server, right? I need to map. Now I have given something here 82:80, right? So what is this exactly? Now, sometimes even in data intelligence, if you're going to analyze the pods in depth, you're going to see the YAML files and other stuff, which I will explain you in detail after this, right? So what is this? This is like I am mapping my host operating system with the container operating system. You got my point, right? So Apache server will obviously run on the default port as 80. Now where we had installed the Apache server inside the container. So inside the container, which is nothing but it's a mini operating system. So I am mapping the container port to our host port 82 so that it will be accessible to the outside port. Okay, so I will just run this again. I'll just give this, let me check it. So probably I'll just remove this container. and then I will try to recreate it again. Let me check. I did not give sudo. Sorry, sudo docker rm-f, and then I just let's. Yeah, there you go. So sudo docker ps. Yes, only one container is running. So sudo docker images. I will list down all the images. Then I will execute this particular command. Okay, it's saying that 82 is denied. Okay, let me just map it with 80 and 80. Access denied. Okay, somewhere I think the port is blocking since I had spinned up this from Azure, right? So this is blocking some port. So probably I'll just have a look into it and see why it is not there. So in the meantime, okay, some of this port is blocking me, but this is what the funda is. So once you have mapped this right, then you will be able to log on, from your browser and then give the public IP of this VM and then port 82. It will directly take you to the Apache homepage, right? So it will. So what is happening there is you are able to access the Apache server outside the container. And how you are able to access it, because you have already mapped the port number here with the host operating system, and then you will be able to access it, right? So, but this is the funda. Okay, so now you guys have a clear understanding of what we are doing here. What is container? What is an image? How do we run it, right? Yeah, so probably you will be able to update. You can pull the same image and then so for as I know, we usually give it in the update mechanism is also there in the Docker Hub repository. Also update is there. So you pull the image and then you do it, and then probably you have to give a new image name, and then it will be available in the Docker Hub. Because right now, if you don't give that image name, right, if you don't give a new image name, then it will be like overwriting the existing base image. So which you can do, but it is not advisable. Yeah, I mean, for version management, they would have they would have done like this. But still, you will be able to pull the latest images, whatever is automatically updated to the Docker Hub repository, because you will be the only one. See, after all the development is done, only you will be able to push the image, right? It's not like then and there you'll be pushing it. Say, for example, today you're working something, you push the image, and tomorrow you pull the same image and do something, and then push it to the by giving a new image name, you can push it to the Docker Hub repository. See, I mean, we can get into depth. Docker is again an ocean, right? But whatever we had just shown you is the basic understanding of what an image is, what a container is, how do we run it, how do we pull the images, push the images, any changes, how do we work. So this is just the very basic that we had shown you. So Docker and Kubernetes itself is a 20 or 30 plus hours of training altogether. But I hope, with this, you got at least a basic understanding of what it is, correct? So tomorrow when, Ganesh is going to walk you through the pipeline modeler and creating few images here and there. So you should not go blank, right? So hope you have got a basic understanding, correct? Anyone, has any concerns, or you want me to repeat any of the things that I had already said? I really wanted to show you that accessing this Apache server, but somehow some port is blocking. So even even with this image, whatever we had already built, right, you can also again create a container, commit a new image, and then do something. So if you see the image size, the base image whatever we had taken was 72 MB, but the image whatever we had committed is 210 MB. That is because of the Apache server that we had installed. Right now, if you package it and give it to push it into Docker Hub, and say for example, if Ganesh is the tester, Ganesh can pull this image, and he don't have to worry about the environment, because this itself is an environment that you had bundled. Correct?
Yeah.
He doesn't have to worry about anything. He just have to pull the image, spin up the container, and then check whether the application is working or not. Done. So as easy as it is, guys, you are able to see, right, how we are slowly moving from the traditional approach to the new generation open source technology world, how we make things easier. Now, if I have to correlate this to SAP Data Intelligence, SAP Data Intelligence has the images like this. These are all the images that will be available in your SAP repository. Pipeline modeler images, monitoring images, system administration images. Like this, you will have hundreds of images corresponding to SAP Data Intelligence. Each and every image will be copied from SAP repository to customer repository, right? So this is the basic understanding. Not many people know this actually, how the behind the scenes work, but now I hope you would have a good understanding. Tomorrow if someone comes and asks you what about SAP repository, what it contains, how it is moving to customer repository, what are all these images, you should be able to have an outstanding answer, right? So I just did some changes, but looks like I don't have the permissions to open up the port in my Azure network. The administrator has not given the permission, so that is why probably it's not working. But I just did some changes, created a new image, and if you're able to see here, right, my port 82 has been mapped to port 80 of this container. So if I do a sudo docker images, I have created a new image. So this is the naming convention that I had followed. Okay, so this is Venkat9890/my-apache. I will tell you why I have followed this. Now, what we did all this time was we downloaded an image, we installed Apache server, and then we port mapped, and when we want to access it, we can access it. We opened up a container right now. This is still in our local system, right? So if we have to push it to the Docker Hub, right? So if I have an account in Docker Hub, if I have to push it to the central repository, what is it that I have to do? So first of all, I have to log into my Docker Hub. So via CLI. So what I will do is I'll just do a sudo docker login. Now, what is the username? So this is the username that I had used to create the Docker Hub. So, and the password, just a second. Yes, login succeeded, right? So I was able to log on to my Docker Hub via CLI. Now, what is a command? To push this images, we have to sudo docker push, and then the Venkat9890/my-apache. Okay, so I am pushing my image, whatever I had created, the new image, to my Docker Hub, right? I will show you. So this is a naming convention that has to be followed whenever you have to push your image to the Docker Hub repository. Okay, so so I have my repository. So I have already created a repository, Venkat9890/my-apache, and this is the repository name that I had given it as an image name, and then it has automatically uploaded it here, right? So this is what it is, and if I have to pull my the image, right? So I can just use this command to pull the image from my Docker Hub from this repository, right? So it will automatically pull this image from this repository. So this is how you do a push to your Docker this thing, and then you pull it from the Docker repository, right? So with this, we close the session for Dockers. There is also one more concept which I will explain you, which is called as Docker file, and then with that we will close the Docker section, and then we will move ahead with the Kubernetes. Okay, so we have something called as Docker file. Okay, so now what is it Docker file is used for? Now imagine whatever we had done is a manual activity, right? We pull the image. Just let me quickly share that. Right, so we pulled the image, and then we had pushed the image, and then everything was manual activity. When I say manual activity, we had logged into the container. I had manually restarted the Apache. I have installed the Apache and then restarted the Apache, and then I had exited the container. So these are all some of the manual activities. But this is a very small step that we had done. Is it possible for us to automate this? Okay, if I just execute a script file, okay, if I execute a script file, automatically these things should be able to handled by the Docker. Is that possible? Yes, we have a concept called as Docker file, which will allow you to write certain set of commands, which will execute in sequential order, and then you don't need to do anything. You just execute that using the Docker file. Automatically, everything will get updated. Okay, so I will just go through few of the commands, and I will also show you how the file will look like, so that in your environment, it is always advisable to use the Docker files instead of going inside the container and then manually doing the stuffs. So I will open up my whiteboard. I hope my pen should be charged by now, and let me know if you're able to see it. Okay, so I will just split this portion into two so that you are aware of what is happening. So, okay, so we have these basic commands from add, run, cmd, entry point, and then we have environment variables. Okay, so these are all the different commands that will go inside a Docker file that you create. So now, what is the from keyword is used for? From keyword is used to define the base image on which we are building it. Okay, now can anyone tell me what is the base image that we have used in our scenario for building up the Apache server and all those stuffs?
Also one that starts with Ubuntu or something, right? Like Ubuntu.
Yes, so we had the Ubuntu base image. So this is the base image that we had started. We always need a base image to start something, right? So we need, obviously we need an image to start working on, be it Ubuntu, Fedora OS, Windows, whatever it is. We need some image to start our building our environment, right? So this is what it is. From is used to define the base image on which we will be building. Now, what is the second command that we are going to do here? Okay, so the second command is add. Okay, now add is used to add the files that the container is being built. Okay, so it will add the files from the current directory and then put it into the required directory that is available inside the container. Say for example, if I'll not give the add here, okay, just because there are few more steps, but just to, it will add all the files from one directory to another directory. Okay, so this is what add does. Now, when I give the command, you will be able to easily understand what it is. Now, third command is run. Okay, what did I do for Apache server? I did an apt-get update first to update the repository, correct? So this is what I had done. Now, what is the next thing after this I had done? I had installed the Apache server, correct? So apt-get install Apache 2. See, guys, these are individual commands that we had already given inside the container, and then we are just trying to make a file out of this. Okay, so from the base image, I run the update repository in the base image, and then I install the Apache 2. Now I am adding a certain file. So .var/www/html. Dot represents the current working directory. Okay, so whatever files that are available in the current working directory, it will get added to this var www.html. So this is your Apache server. As soon as your Apache server is installed, this path will be available, and whatever HTML files that you had given here, you can access it through the Apache server. So we are indicating, say for example, if you have an HTML file in the current directory, the dot, it will automatically pull in and it will put it in this path so that you will be able to access it. This is what add command will do. Now we have the cmd command. Okay, cmd command is probably all the important commands are over. So cmd command is used to run the commands on the start of the container. So whenever you start the container, these commands will run. Okay, say for example, if I have to run this Apache as a foreground service, then I will just use this command, Apache ctl. I think it is -d, yeah, foreground. So if you do this, it will probably run it as a foreground service. Your Apache services will be running as a foreground. Now, this cmd command is only at the start of the container. Only when your container starts, this command will run. This command will not run until and unless you start the container. Okay, and then we have something called as entry point. Okay, so entry point, whenever you start the container, if you have any additional commands that are going to get executed after the start of the container, entry point will execute. Okay, but cmd will not execute. Say for example, if you have to start the container, we gave some command, right? We gave the command as sudo docker run -it and then -d and then the image name, correct? Now, if you don't give any other additional commands after this, CMD will run. Any other additional commands that you give here, CMD will get ignored and entry point will get executed. Entry point is irrespective of whatever command that you give for starting the containers. Even if you have any commands post this one, it will accept. Even if it is not there, it will accept. But CMD, apart from the run command, if you give anything, any other parameters are specified, then it will not run, right? So these are all the basic commands, and this is how you create a file. And env is nothing but your environment variable. You can set the environment variable in this file. Okay, so I will just quickly show you how to create it. Okay, how to create it, but I will not run it because considering the time, I will not run it. Okay, so just I will go back to my putty, and then I will show you what we can do there. So what I will do is, first of all, I will make a directory here. Okay, I will make a directory called as Docker files. Then what I will do is I will create a Docker file. Now nano Docker file. So this is what I'm creating. So whatever I have given there, I will just give it here. So probably, I will just give a very simple command. I will not give whatever we had given. Okay. So just for your understanding. So from Ubuntu, yes, from the base image, run app-get update. It will update the repository. So what I will do is I will do a CMD. I will do an echo, and then this is a text. Okay. So I'll just quickly save this. Right. So I will just do a cat Docker file. Yes. So this is what it is. Now, okay. So I have created this Docker file. How do I build? Next is I have to build this Docker file so that it is available as a image for me. Correct. When I start building this file, it will build an image automatically. So what is the command for it? So sudo docker build from the present directory, and then I build a custom Docker file. See, it is running. You are able to see here, right? So from Ubuntu, step 1/3. Step 2, run app-get update. Now the third step is running, right? So successfully built, running, CMD echo. This is a test. So now if I go for sudo docker images, I will have my custom Docker file ready. Now I will run this sudo docker run, right? And what will be the command for it? And then I will just see fmd and then image ID. Okay, you see, as you're able to see here, this is a test. Whatever I had given in the step 3, right? CMD echo, this is a test. So what we did is we had a simple Docker file. It's a plain text file. We had given the commands from the base image, build, and then do an update repository. At the start of the container, you just do a simple echo and then return me this is a test, this value. So when I do a Docker run, the container will start. You know, right? The container will start at the start of the container. This is coming because CMD used to execute it at the start of the container. Okay. Now again, if you want to push it, you will be able to push it. You can then pull it from the image repository and all those stuff. Okay. So one more quick trivia before we move on to the next topic. So we have something called as Docker volumes. This will not be much useful to you, but just as a trivia or a fact, in order for us to persist the data, say for example, if I remove this container, then all my data is gone, right? Until and unless I publish the image or commit the image, all my data is gone. But if you attach a persistent volume to this container, even you delete the container, you can recreate the container using the data that has been saved in the persistent storage. So there is a separate section how you can actually attach the persistent volumes to your Docker images. So it's a big topic, but these are all the important things that you have to understand from data intelligence point of view. Okay, how to build a custom image, what is a Docker file, and then what is a container, how to start the container, how to get inside the container. So these are all some of the basic commands and overview of the Docker, that I really wanted to show you in the system.
All right, let's test your knowledge. Here's a question for you. What is the primary purpose of the Data Hub in SAP Data Intelligence? Option A, to store and manage data. Option B, to prepare and transform data. Option C, to build and deploy a machine learning model. Option D, to visualize and analyze data. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, ready to dive into the world of managing supplies? Our SAP Data Intelligence course is here to guide you through. You can tackle it at your own pace right here on our platform. In this course, you'll explore SAP Data Intelligence, which is like a toolkit for planning things, ensuring we have enough products and getting them where they need to be. From the basics to advanced strategies, we've got you covered. Our experts crafted this course with their wealth of experience. Your instructors are seasoned pros, dedicated to helping you learn and addressing any questions you may have. And guess what? Our students rave about how helpful this course is. Folks just like you have found it incredibly valuable. And the best part, it's super affordable, so you won't have to break the bank to learn. Ready to become a SAP Data Intelligence Pro? Sign up on our page now. For more details, visit ZaranTech's website.
We will move on to the next topic, that is Kubernetes. Okay, so now before I deep dive into Kubernetes, so I had already told you about the monolithic architecture, right? What is the disadvantage of a monolithic architecture? So if any one of the modules is wrong, then probably it might bring your entire system down. Same case, we had an example with data services. Your CMS is down, yes, your entire system will also be down. So that shouldn't be the case. Okay, now why Kubernetes came into picture and what is Kubernetes? Now I will give you an example. Okay, so the Docker images, the data intelligence architecture, whatever we had discussed, all these things, right? We call it as a microservices architecture. Okay, so we call it as a microservices architecture, right? So now assume that I am building an e-commerce application. Okay, so in my e-commerce applications, I have a few images. One is payments. It's an order page or payments page, and another one is probably notifications. Okay, and another one is probably ordering, and another one is probably customer service. Okay, so assume that these are my application components. Each of them are images on their own. So this is a Docker container image, this is a Docker container image, this is a Docker container image, and this is a Docker container image. Okay, now this is very simple, right? When you see okay, we have 4 components, 4 images done. When your application is going to consist hundreds of images, okay, I will show you I will try to show you the images also, how many images SAP Data Intelligence are having. I think it is having more than 50 or 60 plus images, right? So if it is going to be 50 plus or 60 plus images, how we are going to handle it? We are again back to square one, right? Management overhead. If any one container or one image fails, how do I know whether that container is failing? How do I do a health check? So how is it possible to manage all these containers? That's where Kubernetes have come into picture. Okay, so you have Kubernetes here, and then you will have containers, container 1, container 2, container 3. So Kubernetes will be able to manage your container. So it is a container orchestration solution. Okay, So now, like Ganesh was explaining you, Kubernetes is from uh, Google. It was developed by Google, but we also have other solutions like something called as Docker Swarm. Okay, so Docker Swarm is also one of the container orchestration solution, but it is not predominantly used. We use only Kubernetes. Okay, so now what are all the advantages of Kubernetes? As I had told you, right? So it is a container orchestration solution. So Kubernetes will automatically do a health check. Okay, it will automatically do a health check on your containers. It will have a load balancing mechanism. Okay, so it will have a load balancing mechanism. So I will just put a small diagram here. So C1, C2, C3. You guys know what is load balancing, right? So if C1 is heavily loaded, Kubernetes will automatically detect and it will automatically send to this particular C2. So this is not the actual diagram, but just for your reference, for easy understanding, I'm just giving this. I will probably draw a detailed more diagram and then I will explain you in depth, right? And then we have resource usage monitoring. So we will be able to monitor containers, okay, on a continuous basis and see which one is consuming more CPUs or which one is least used and all those steps. Okay, so with Kubernetes, we don't have to worry about how many containers are running behind. And Kubernetes, as I had told you, automatically takes care of health monitoring. We only have to worry about what kind of service that we require. What is the new feature development that I have to develop? So more emphasis will be on development rather than you are worrying about all these infrastructure services. Correct? So this is one of the most important points. So we lay more emphasis, okay, on development rather than you worry about underlying infrastructure and all those steps. Okay, so so these are all some of the advantages of Kubernetes. Now I'll give you a basic diagram of how Kubernetes will actually work. Okay, so in a typical scenario, we have something called as Kubernetes master. Okay, we have something called as Kubernetes master. We have the K node 1, K node 2, K node 3. Okay, now we have three nodes: node 1, node 2, and node 3. So these are all nothing but your slave machines. Slave machines. I'm not saying containers, slave machines. Okay, so now we have a master node and then we have a slave node. So master node is like the heart. It will control all your slave nodes. Okay, I was about to I have a detailed architecture which, in case if time permits on day 4 or something, I can also, if anyone wants to learn what exactly in-depth Kubernetes architecture is, probably I can explain you guys. We have a lot of components in place, and then we will see. Okay, so as of now, I'm just telling you what is required for you to hear. Okay, the job of the master is basically to schedule the container. Okay, schedule the container, monitor nodes, and then monitor pods. Okay, monitor nodes and monitor pods. Now the node does the job of processing or sending API calls, etc. When I say node, this is the slave machine. Okay, slave machine. So it does the job of processing. It consumes the power of the virtual machine, or in case if it is a VM, and then it does the job of processing. So your Kubernetes will run on both master and slave. Okay, so if I have to tell it to you in a simple words, Kubernetes software will be running on both the master node and then it will be running on both the slave nodes. So it will look like it will be acting as a one system for you, though they are segregated into master and nodes. Okay, so we have this is a probably very simplified Kubernetes architecture, and obviously it's just following a client server architecture where it sends the request and then receives the request, and and all those steps. Okay, so now we have something called as deployment, and then I'll put it here. I'll just draw 3 diagrams here, and then this is your pods and this is your node. Okay, So now what is a deployment? Okay, so a deployment basically takes care of number of pods running inside a Kubernetes cluster. So your deployment is the one which is responsible for telling you, I need these many pods within my node. Okay, so I have a sample file which I will probably show it to you as well. So that in the sample YAML file for deploying it, you will mention how many pods I would require for my application. Say for example, for the payment module, I would require 3 pods. Okay, so 3 pods will be automatically deployed inside a node 1. Okay, so inside your virtual machine, you will have 3 pods running. Now these 3 pods will have the same images running. So even if one of the pods goes down, these other 2 pods will still be running. Okay, so that is the specialty of this deployment. Now we will take another example. Okay, so if you want to go to tcs.com or if you want to go to ZaranTech.com, right? So if this is my application, I'm going to build it using the Docker images. How will Kubernetes know how to serve the website? Okay, so given that your application is going to sit inside a node which is sitting inside a pod which is inside a node, so how will the Kubernetes know where I have to redirect? Now, for a business user like Murali or like Ganesh or like Venkat, we are all business users, what is the access that we will be having to? We will be having access to the application URL, tcs.com, ZaranTech.com, right? Apart from that, we don't know anything. And our main ultimate goal is access the application. That's it. So when you hit enter, say tcs.com, hit enter. Now what is going to happen? It will redirect to the appropriate node and then the appropriate pod where the image is sitting. Okay, so how will this be done? Now nodes will be having certain IP addresses and master node will also have some certain IP addresses. Now using any of these IP addresses, the application can be accessed. Say for example, your slave node is 192.168.1.1 and we have the master node say like 102.211.123.111. So this is something, this is your master node IP, this is your slave node IP. You can either access the application via the master node IP or you can either access via slave node IP, right? So I will tell you how this is going to work. Okay, so now we have something called as, because the next question immediately that will come to you is, say for example, this is my payment images. My payment images are sitting inside all these 3 pods in the slave node 1. Okay, now I have one more slave node 2. Just excuse my handwriting. Okay, so I have slave node 2. This is running my orders. This is hosting my orders, and pod 1 and pod 2. I have 2 pods. This slave node 2 is having IP address, say for example 192.168.2.1. Now, how will I know as a user? If I go to orders, it has to redirect to slave node. If I go to payment, it has to go to this particular node, right? So we have a concept called as service. Okay, we have a concept called as service within Kubernetes. Now, what is this service? This service will have access to all of your nodes, right? So, say for example, this service will have access to all of your nodes. This service will actually know what is sitting inside each and every node where I have to redirect. Okay, now, so this is an internal load balancer for all the pods which are running now. If there are 3 pods which are running inside my cluster, right? Now, in front of every deployment, we have this service. So it does nothing but expose the internal service to the outside world for accessing. So this is an internal load balancer. So once the user requests are hit, it will directly, the service will consume this and then service will know which pod I have to hit it. Okay. Now, so for each and every, this service will have this service will be pointing it to slave node 1, and we have one more service, say service 2, it will point to this particular node. So each and every node will have their own internal load balancer, own internal service. Okay, so it knows, service 2 knows that orders, I am hosting orders. Service 1 knows, okay, I know I know where the payment is sitting because I am associated with the name 1. So this is how the service knows actually. Okay, now the point comes, have you guys heard anything about ingress controller? Ingress. So we have the Nginx ingress controller sitting here, right? So ingress controller will have all the details of the service. So if I go to say ZaranTech.com/orders, it will redirect to this particular node and this particular pod, and this image will be accessed. If I say ZaranTech.com/payment, right? So this particular service will be accessed and it will redirect to this particular node. So we have a deployment just to summarize, we have a deployment and we have a number of pods sitting in the deployment decides how many pods should be available for the image, and then we have a number of nodes, and each node will have their own service, and these will be connected by the ingress controller, which will say, for example, this ingress controller IP is 1201.102.103.202. Then this is a URL that will be mapped to ZaranTech.com, right? So this is the funda. Okay. Now you are very clear, right? What is pod? Now inside these pods we will have images. Inside these pods we will have the images, because your deployment file, it not only tells how many pods it has to be there, what image I have to put inside each pod, right? So your payment image will be there inside the pod, correct? So whatever image what we had created, say for example we had created an image of Venkat 9890, correct? So this is the image that we had created. So this will be sitting inside this pod. Now where you will be giving this in the deployment file. I need to have 3 pods, and what is the image that I have to use? I will be using Venkat 9890. So each pod will have this particular image. Now this image will be your payment image, which will be accessed.
Makes sense.
If I have node 1, say this is a virtual machine 1, I have already logged on to the virtual machine. What I will do is I will download Docker. First I will download the Docker, right? Then what I will do is I will deploy. There is a deployment which is in the YAML file format, which I will show it to you now in some time. The YAML file. Now in this deployment, I will deploy the YAML file to the Kubernetes cluster. Okay. So before all these things happen, you need to set up the Kubernetes cluster. So when I say set up the Kubernetes cluster, in the sense of if it is going to be AWS, as I had told you, right, master node and the software, you have to install the Kubernetes software and then make it ready. So once that is done, you will deploy this YAML file into this Kubernetes cluster, and then this deployment, if it indicates 3 pods, so this VM will have 3 pods. And what is the image? We have the Venkat 9890 image.
Got it. Okay.
Right. Every information you will have it in this deployment file, Murali. Okay, so now we will just go through few of the terminologies that we had discussed, so that you are clear on what is happening. Okay, so Kubernetes cluster. Okay, so this is one. What is a Kubernetes cluster? This is nothing but your the software that is installed on a set of physical or virtual machines, probably your association of the master and the slave node. The entire setup is called as a Kubernetes cluster. Okay, so we have the node, so which is nothing but your VMs or any other physical machines. Okay, so any other physical machines. Now what is a pod? Pod will nothing but it will contain the images which will run inside the nodes. Okay, images running inside the node. Okay, now, okay, so these 3 things we are clear. Now what are all the other steps that we need to interact with the Kubernetes cluster? Okay, if I ask you, we have set up the Kubernetes software, but how do we interact? Okay, so very similar to your how I can give you an analogy. Say, okay, so for accessing your Ubuntu machine, right? So you guys have tried, spinning up a virtual machine in AWS or Azure. You have any experience in that? Can anyone tell me if you have any experience in spinning up a virtual machines from AWS or Azure?
Not this. I don't think so. Forget.
Okay, so you know about Putty, right? You know about Putty.
Yeah.
So what is Putty? Basically, to log on to the system, we use
Particular.
Putty, right? And then
Yeah.
once we log on, the CLI console will open, right? The command line interface will open, and then this CLI will be able to use to interact with the Ubuntu machine, correct?
Yeah.
Now, very similar concept. We have something called as kubectl, kube control. This is called as kube control. So this kubectl is used to interact, okay, with your Kubernetes cluster. I will show it to you on the system also, okay, how we can use this kubectl commands, and then what are all the things that we could see, and on all those stuff. Okay, so now we have kubelet. What is kubelet? So kubelet is not a command. Only kubectl is the command. Kubectl is your access. As if you want to access your cluster, kubectl. That's it. As simple as such, right? So kubectl. These are all internal concepts. Probably you can keep it in one corner of your mind. If tomorrow someone comes and asks you what is kubelet, then probably this is an agent. Okay, this is an agent which runs on nodes, all the nodes. Okay, and without this kubelet, your master will not be able to communicate to your slave node. So for establishing a successful communication between your master and the slave node, so kubelet is required. Okay. Okay, guys. So I am just to give me a second. I don't want to go into in depth and tell you about what the master node contains, what the slave node contains. I don't think that will yield. That will probably day 4 we can take it up in case if you want additional details, right? So let me. Okay. Now I had also explained the kubectl command, and so yeah, so I think it's time for we showing some YAML file. Okay. I'll just clear the canvas. Okay. So now, whenever we talk about this particular Kubernetes, Dockers, we have something about YAML files. Okay. So we have something about this YAML file. Just give me a second. Just give me a second.
Meanwhile, just a little background about YAML. So YAML is nothing but a simple file format which is serializable. It's similar to JSON, CSVs, etc. Right? But it's more of a key value thing, similar to JSON. But YAML is increasingly the preferred serialization format of choice when it comes to cloud native technologies. I'm not sure why, because JSON is slightly better than YAML, but yeah, that's how it has been evolved. So it's usually used to create some configuration values which can be then fed into the systems.
Okay. Yeah. So sorry guys. Yeah. So I will just write a simple YAML file. Okay. I'll just write a simple YAML file. The way how we did it for Docker file, right? So I'll just probably this is how. What is a YAML file is you will deploy this file to the Kubernetes cluster. Okay. So you will deploy this file to the Kubernetes cluster. Now, how does a YAML file look? Okay. So this YAML file is also a little bit important for you to understand, because tomorrow, in case if you have any issues, you will be able to debug the YAML files, whatever has been deployed into the deployment, and then you will be able to see what has gone wrong, what image has been used, and all those things, right? So we have first API version, we have apps, we have v1, okay, we have kind deployment, okay. So we have kind as deployment. So this is how your YAML file will look like. I'm just writing down a very simple YAML file. Now, this kind is a deployment which you are indicating to the Kubernetes cluster that I am deploying something to you. I am deploying an image to you. Okay. So I am, this is a deployment YAML file. Now, what are all the other kinds that are available? Other kinds that are available, one example is service. Now, this is not a deployment, but I want to enable a service. Right, I want to enable a service, say internal load balancer, for you to access the images, access the deployment. So this is the another kind. Either the kind could be service or the kind could be deployment, depending upon the use case. Right, now we have the metadata. Okay, we have the metadata, and then we have the name. Now, what is the name of this YAML file? So we have Nginx deployment. So okay, so this is a standard Nginx YAML file. What I'm showing you, Nginx is nothing but your probably like an Apache server. When you hit the Apache server, you'll be getting a page, right? Welcome to Apache. So a web server. Probably this is Nginx is also one of the servers. Now this YAML file is used to deploy the Nginx server. Now, so we have the labels. Okay, so we will be naming this particular Nginx deployment as Nginx. Okay, now this is the first half. So what are all the important parameters that are here? So we have the kind, and then we have the metadata. We have given the name of the deployment as Nginx deployment, and this is what you will be using when you pass the kubectl commands. So this is the name that you will be using, and we label it as Nginx. We're just giving some name to this application as Nginx. Now comes the most important part, that is specifications. Okay, this is a single file, specifications. Now specifications, replicas 3. So you remember the previous diagram that I had told you, how many pods inside a node? Who will decide? This YAML file will decide. When I say replica 3, okay, you will have 3 pods containing the same image. If you have 4, we will have 4 pods inside a single node. Okay, now this is the replicas will decide this replicas will decide how many pods have to be spinned up. Okay, and each pod will be having the image. Now I will quickly go to the image, and there will be I'm just ignoring few things in between. I will directly open the file and show it to you. So there will be also one more specifications, say containers. Okay, containers. Now what is the image that I want to pull? I want to pull Nginx image. This is a proper image. Okay, so this is the name of the image, and then I will specify the image here, like Nginx, like the version 1.15.2 or something. So instead of Nginx, you can use Ubuntu also. You can use some other custom images that you had already built and all those stuff, right? So this is where you specify the image. Okay, now this is where you specify the replicas, and this is where you specify the images that has to sit inside this particular pods. Now we have one more item called as ports. This port will decide what is the container port that this image will have to run, 18. Okay, now guys, you remember we did something, we just used the port mapping, correct? So we did say like I just executed this command, sudo docker
8082
run yes -p 82 to 80. So this 80 comes from the container port that you give it in the YAML file, and then you are mapping it to the 82 port of the host system, which is outside the container. Okay, this is a container port which you are telling that this has to run into. This could be anything. If you want to run it into some other port, say like 9001 or something, you can easily give it, and then you can map it to 82 and 9001. Okay, so this is the basic funda of a YAML file. Any doubts till now? Any doubts till now?
So this would be like how it's like one YAML file for, like, if we are, is it just that for the node level, or how would that goes? Or we could be able to come up with a YAML file where like we can able to use at the cluster level, like where if you want to deploy something or build something.
Yes, you will be able to do it at the cluster level also.
Okay.
Yeah, so Murli, this is the part where where, one of the instances of our experiences where, we had to change an existing ingress controllers YAML file of the customer, right? That was because they already had, a huge cluster running, and they said, why not deploy it in the same cluster? We don't want to spin up a new cluster because it increases the administration cost. So which is why all these settings we had to do in the existing file of the same Kubernetes cluster. Right. So this is something which comes up in the installation, setup, and configuration part. Right. So without this, no project can start, right? So these are the primary things. I mean, even if we don't know, we should get in the people who know these stuff to do this. Yeah.
Okay. Yeah. Excellent.
Okay. So we have, I will, just give you few of the commands, which probably you can also note it down, which will be very helpful for you. Okay. So we use the kubectl command to interact with the cluster. So to delete an existing deployment. Okay. So we use delete deployment, the YAML file which you had deployed, right? If you want to delete kubectl, delete deployment and the deployment name. In our case, the YAML file, the deployment name was Nginx deployment. So you have to give that in case if you have to delete the deployment. Okay. Now, so these are all some of the commands which I'm writing it down here, and then I will show it to you in the system also. These are all some important commands. Okay. So get pods, kubectl get pods. Okay. -o wide and -n namespace. Okay. Now this is your Kubernetes namespace. Okay, I had forgotten to tell you what is a namespace in the important terminologies which I had told you. Kubernetes namespace is nothing but like your identifier. Say for example, you have your employee number, right? So now you guys belong to the same team, but you have each and every employee number associated to you, right? So say for example, if me and Ganesh, we are working in the same team, but we are working on different projects which uses the same cluster. So we use a different namespace to deploy our projects. Okay. Now, say I'm working on e-commerce application, and Ganesh is working on some other, say, game application. Okay. So now what I will do is I will use the same Kubernetes cluster. It's the same cluster because it's a very powerful cluster. Say it's 256 GB RAM. Now, I don't want to use this particular cluster only for my e-commerce application. I want to use it for game application also. So what I will do is I will create a separate namespace, say Venkat or e-commerce. Okay. And Ganesh will be creating like Ganesh or gaming namespace. Okay. So all the e-commerce applications will be deployed under e-commerce namespace. So when I do this command, kubectl get pods -o wide -n, say e-commerce, it will give only the pods which are running under my e-commerce namespace. Because I don't have to worry about the gaming application, right? So what will happen is, if you give the same command with -o wide and -n all namespaces, okay. Now, if you give this command without any giving specific namespace, it will give you all the pods which are running for all the applications, all the namespaces. Sorry. Okay. So if you want to filter it for your own namespace, you can use the namespace. So now for deploying, if you have to deploy the YAML file, what is the command that you have to use is kubectl create -f deployment.yaml. Okay. So this is how you will be deploying your YAML file to the cluster. Right. So these are all some of the important concepts of Kubernetes. Right. Now, you know why Kubernetes is used, how to manage the containers, what is the advantage. Without Kubernetes, what is going to happen? If I have to deploy my application into Kubernetes, what should I do? And how the Kubernetes architecture is, how it is able to communicate with the pods. What is a pod? What is an image? What is a node? What is a deployment? So guys, you have at least a basic understanding of what all these stuff is. So what I will do is, we have all been talking about Docker images we have created, and so for Kubernetes, right? So unfortunately, I don't have the time to set up the board, master and the slave nodes and join it. So do it in the proper traditional way. So I can give you a heads up and then how it is done in the Azure environment, right? So you are able to see my Azure environment right now, correct?
Mm-hmm.
Okay. So now what is happening here is, this is my Azure environment, and here we can easily create a container instance. First, let me see how different, or I mean, how easy these public cloud vendors have made our life easier. So I choose my subscription. Probably I'll just create a new group, resource group, say like Docker test, right? And then I click on OK. Now, what is the container name? So my sample container is what the name is. Okay. And the region, I can select any region. So image source. So I have three places. One is quick start image, one is Azure container registry, and another one is Docker Hub or Docker registry. So Docker Hub is what I had already shown you, the account where we had created in the Docker Hub, and Azure container registry is very similar to Docker Hub, wherein Microsoft Azure provides a place to store all your images. Like how you are going to store it to your Docker Hub, you will also be able to store all the images to your Azure container registry. Instead of pushing the images to Docker Hub, you will be able to push the images to Azure container registry also. Okay, so now I'm not going to pull any images from anywhere. I'm just using the quick start image. So this is a demo image, right? Now if you see, we have the demo image, that is ACI Hello World, simple Hello World container. Now recommended size is 1 CPU, 1.5 GB. So this is when, as soon as I hit the create button, what will happen is it will immediately deploy the container, and then the image will be running on top of it, right? It will spin up a VM behind the scenes. Behind the scenes, it will spin up a VM. It will spin up the container using the image, whatever is mentioned here, and then this hello world mechanism will be running. Now, these are all sample images. Now, Nginx image. If you want to spin up an Nginx container, you can select this. So, just for example, I'm selecting this. Okay, Microsoft ACI Hello World Linux. The sizes, if you want to change the size, you'll be able to do with this. Now, I review and create. Okay, I hit review and create. Now let's see what happens. Now here you are able to see, right, the OS type Linux. So this is your container OS, guys. This is your container OS, like how we had deployed an Ubuntu container. So here the Linux container will be deployed. I'm not sure what flavor this is, whether it is an Ubuntu or Fedora OS, but most probably it should be Ubuntu, I guess. But this is a Linux based container OS, right? So I just hit on create. Now it is initializing the deployment. So the deployment is in progress. So let me quickly go to virtual machines and then see how it is. As I go to resource. Okay, so this is my container instance. My sample container is ready. So now I have a public IP associated with this, right? So if I copy and paste this, let's just do this. Okay, so you are able to see this, right? Welcome to Azure Container Instances. Now I just gave my public IP here. Okay, the public IP to which the container is spinning up, where it is running. So you see, right, how many minutes we took, for deploying this container and then pulling the image. So, and how much time it did for us to manually do it. So we installed Docker, then we pulled the image, we did some changes and all those stuff. But these container instances provided by Azure or AWS will definitely make your life easy. Once your image is up and running in either Docker Hub or Azure Container Registry, you can easily pull the images from there, and automatically the container will be spinned up. Okay, so I just wanted to show you how the container instances also work in the Azure area. Now we will just take a step back and then we will go for Azure Kubernetes service, right? So now we have seen the containers, so probably we'll just see the Kubernetes services, right? So we don't have any Kubernetes service as of now. So I will also send you few links in case if you have to set up the Kubernetes manually, setting up the master node, setting up the slave node, how to join the slave node to the master node, and then how to set up a Kubernetes dashboard. So Kubernetes dashboard is the one which will actually give you the health of the containers, which will actually tell you which container is running at low percentage CPUs, high percentage CPUs, and all those stuff. So Kubernetes dashboard is also one of the important feature. Unfortunately, we do not have the required infra or time to set those things up, or else I would have easily shown it to you. But nevertheless, okay. So this is the best part. Okay, Azure Kubernetes services is the best part because this is how the actual installation will also be done. So this is what we'll be doing. First of all, we will be initializing the Kubernetes services. So this is a first and foremost thing. So I just click on add here and add a Kubernetes cluster. So here, I just create a new resource group, K8 as new, and then I'll just give the Kubernetes cluster name, my K8 as cluster, right? So region where this has to get installed, and they have recently added the availability zones too. I think it was not there previously. Right? Okay, we have the availability zones and we have the Kubernetes version, whichever you want, you can select. So previously we had been supporting only 1.14 and 1.15. These are all the Kubernetes versions that SAP Data Intelligence were supporting. But now I think they have extended it to 1.16, 1.17, and 1.18. So here I will just select a sample. Just go for 1.16.15. Now this is the node size. Okay, so this is the size of the node. So size of the slave machine, and this is the count. Like how many slave machines do I require? I need, say for example, 3. Now, what is the size of this machine? So if I just select this 3.5, just go for this B2M as 8 GB RAM and 2 vCPUs. So I will have 3 nodes, each of the node having 8 GB RAM and 2 virtual CPUs, right? I will configure my node pools. So here we have okay, just a second. I wanted to disable this. I don't want the availability zones. Yeah. So now here the important concept which I want to tell you is virtual machine scale set, right? So your slave nodes will be running behind a virtual machine scale set if I select this option. If I don't select this option, then it will not be running behind a virtual machine scale set, and it will be as if a normal virtual machines are there. Now, what is the difference if I select virtual machine scale set and if I don't select? What is the difference? So, Murali, you brought out a very important point, right? If one of my node goes for a toss, or if it is failing, or if more capacity, more users are coming, how do we scale it? Right? So behind the scenes, your virtual machine scale set has the ability to scale it depending on the parameters that you define. Say, for example, you can define a criteria saying if my vCPU, if my CPUs are going to hit a CPU utilization percentage of 70%, then scale up by one more node, or scale down by one more node if the CPU utilization is at 25%. So like this, you can bring in your own conditions, define the scalability criteria. Okay, so this is how Kubernetes is so flexible when I talk to you about scalability, right? So that behind the scenes, this is being carried out by the virtual machine scale set. In Azure, I think this would be carried out in AWS by, I think it goes with some other name, I forgot the name, but there also we have this automatic scaling mechanism, right? So now I will not explain all these options, so I will just quickly deploy it, and then I will try to deploy the YAML file, and then I will show you how to do it, right? So network configuration, we have KubeNet and Azure CNI. Azure CNI is nothing but your Azure Container Network Interface. So one of the important questions, which you guys have forgotten to ask is, I have multiple pods in a node, right? and say I have node 1, I have multiple pods. I have node 2, I have multiple pods. But there should be a communication mechanism between these pods. So we have something called as in Azure Container Network Interface. For each pod, IP will be assigned, and they use a communication mechanism like Calico, Flannel, or even Azure network interface to communicate between each other. Right, so each pod will communicate within each other using their own IP address and the communication channel. So without
between the pods, that's between the pods, right?
Between the pods, right? You are absolutely right. So that's why we are giving all this IP addresses and all those stuff. And you see the network policy. We have Calico and we have Azure. Which one you want to use? We have a lot of other things. I will share you one link where it will tell you how to deploy this manually, from scratch till the end. What are all the different networks that you can use? Here it is given only Calico, but Flannel is there, and there are also 3 or 4 more other networks which you can use. I mean, even I have not worked with any other networks. I have basically worked with Calico and basically worked with Flannel, but I really don't find any difference between these two things, right? But whenever I use Azure, right, probably I choose Azure network because I find it so robust, because Azure will usually have a tight integration with their services, right? So I generally go for this Azure, but there is no stopping. You can even go for Calico and other stuff, right? So, and then here we have the Azure Container Registry. If you want your AKS, that is Azure Kubernetes services, to get linked with any of the container registry, then you can easily create a new registry and then assign it so that your cluster will talk to the images that have been deployed to this private registry. Okay, so now I'm not giving any registry because I'm just going to deploy a simple YAML file and then see whether it is working or not. We have the tags, and then it's running the final validations. So in the meantime, I will just note down the cluster name and the resource group, because I need this to talk to my Kubernetes cluster. Right, so this is my Kubernetes cluster name. So resource group. Okay, so now guys, just be careful in case if you're going to use Azure or AWS. This is just the validation state. We have not yet created, right? So validation is passed. Now we will be creating the Kubernetes cluster. So this will take some time to create, and in the meantime, let me just show you the other stuff. Let me know once you are able to see my machine, Kubernetes machine. Right, so this is one installation. This is a successful installation which has been deployed on Azure Kubernetes services. Now, guys, this is a jump post. Okay, I need a jump post, probably a virtual machine which I need to use to talk to my Kubernetes cluster. That is what we call it as a jump post. Now, this is my jump post. My Kubernetes cluster is ready. I have deployed my data intelligence on the Kubernetes cluster. Now, can anyone unmute yourself and tell me what is the command that I have to use to talk to my Kubernetes cluster? Anyone? What is the command? I have already told you this. This is a very, very important command. If I have to interact with my Kubernetes cluster, what is the command that I have to use? So kubectl get pods. I need to see what are all the pods that are available within my Kubernetes cluster, right? So if I hit kubectl get pods, should be getting an error. See, no resources found in default namespace. Now, what is the namespace that I had given for my DI installation? I don't know. I had forgotten. So in that case, what I have to do is I will give -all namespaces so that all the namespaces will be available. You are able to see this, right?
Yep.
Okay, so these are all the pods that are available for a DI installation. Yeah, so we have all namespaces, correct? So we have all namespaces. Now, when I said namespaces, I was giving you an explanation. What is a Kubernetes namespace? It is like an identifier, right? So when you're in a team, and you are working on two projects, but you are working on a single Kubernetes cluster. So you have to deploy your projects separately in a separate namespace. Say, for example, my data intelligence. Okay, I have deployed data intelligence under the namespace my demo di. Okay, now if you are working in e-commerce application, your namespace will be something like e-commerce, whatever you decide. So along with my my data intelligence pods, I will also be able to see your e-commerce pods also running under the namespace e-commerce if I give all namespaces. Okay, so I will give you an example here as well. Now I have two namespaces. One is my demo di and one other one is SAP SLC bridge. Okay, so when I was explaining the installation mechanism, I told you, right, how you can access the SAP Data Intelligence images. You will not be able to find it in the service marketplace. So you use a tool called as SLCB, Software Lifecycle Container Bridge. So you use this solution.
Oh, that's the one. Okay, got it. Okay.
Yeah.
Makes sense.
So now you will be able to use this, and then you will be able to pull in all the DI images. Now, instead of hyphen all spaces, if I give -n, and if I give this my demo di, okay, so I will be able to see only the pods corresponding to my di namespace. Now, what is the status of the pods? How many pods are running? 2 out of 2 are running. Okay, and we have other statistics as well. vSystem module loader, right? So in case if something is crashed or you might find as terminated error, then you can use commands like kubectl get logs, and then you can give the probably, I hope this should work. Let's see. So if this is the one, so probably we will be able to get the logs of a pod. Okay, probably I think I'm typing in the wrong command. Yeah, but I have to get the right command to check the logs of each and every pod. Okay, but kubectl is the main command that you have to use. Okay, so and then kubectl get pods, -o wide. If I do it, -n my demo di. Okay, so you are able to see the nodes. Okay, the nodes under which each and every pod is running. So this node is running under this. This is the node name that has been automatically assigned by the Azure infra. So these are all the -o wide will give you the IP address, and it will also give you the node under which each and every pod is running. Okay, guys. So this is why I told you Kubernetes and Dockers are very, very important. And each and every pod, right? Each and every pod will have certain images. So vSystem module loader will have 3 or 4 images. We have vFlow graph will have 3 to 4 images. You see here, we have the pipeline modeler pod. So this is the pod. If this pod is crashed, you will not be able to use the pipeline modeler itself. And we have 2 pipeline modeler pods running. And we will have 3 to 4 images under this pipeline modeler, depend on how SAP has packaged the images. Okay, and we have the machine learning pod, we have the Jupyter Notebook pod. So you see, you are able to see this, right? Each and every component has been segregated properly. Jupyter Notebook has a separate pod, pipeline modeler has a separate pod, machine learning has a separate pod. Then your vSystem, vFlow has a separate pod, which is the core pod. And then for administration, we will have a separate pod.
Even the secrets are managed separately. And another thing is, right, if we have, like, for example, we have 6 users right now, right? So each user, once you open a pod for the first time, then only it will be created. Right now, these pods you can see because the users have already logged in and opened it. They opened them once or twice, or they have created some pipeline, which is why you see so many pods running. And every user will have their own. For example, if I open Modeler, if Murli you open Modeler, or Venkat opens Modeler, so 3 different instances of the same modeler, which will open up for each one of us. So now you must be thinking, if I have 100 users, how will my DI take it, right? So as for any SAP system, we know that sizing is an important part, right? We'll be covering the sizing part in the administration section as well. If you have a use case, if you have your requirements mapped out, or if you don't also, so what is the basic level of sizing we have to think of? So as you would have guessed, it does depend upon number of users. It does depend upon, which modules you will be using more, what will you be creating. So we will be getting into the details, but all the pods in front of you, they together make up the entire SAP Intelligence as a software. And all these pods are separate. All of them are running in their own namespaces. They don't have any shared memory. Which is how you can manage tenants. Again, I'll be covering that. But just to give you a look that between the messaging of these 40-50 pods, the entire software comes together. The namespace is nothing but a logical collection. For example, if 10 different teams are working on a same huge Kubernetes cluster, the only way to demarcate boundaries to have a basic level of ownership and authorization, what happens is there is a logical division of all pods into namespaces. How this helps is that a person who has access to only one namespace cannot see maybe other pods, or he might have the ability to see all pods, but he cannot work with them. So it's just a logical differentiation, logical categorization of pods into namespace. It's like buckets. That's all. Namespace can have many pods. I don't think there is a limit there.
No, that is what you're seeing it here, right? Satapa. Say for example, my namespace is my demo DI. Okay. Now this is what it is. Under my demo DI namespace, these are all the pods that are sitting, and these pods belong to which node is what is given here. You remember my diagram? What the outer box was deployment, and inside that we have the node, and inside that we have the pods. So these are all the pods that are linked to these particular nodes, and then their corresponding IP addresses, right?
Big modules of DI, they live within their own pods, right? But there are small modules of DI. For example, system management. It's not that big. So what will happen is DI's Kubernetes instance will place that process within a pod which has enough memory. Right. Same thing happens. What I can do. So when we come to that part, right, I'll show you in the administration and the management section that I can start 10 instances of modeler itself.
Yeah.
But only the most stable link will be used to serve my requests. Right. And if those instances are not being used, Kubernetes will kill them automatically. Right. Okay. And even if I delete all instances from my administration section, I just delete everything in modeler. What will happen the next time I click on the tile of this modeler, a new process will be spin up and it will be placed in a pod which has decent space. And usually modeler is pretty heavy. So modeler will almost always have its own pod. We need to have, depending upon requirements, the environment will change. When we talk about environment, I might say that probably in one team, there are more Python developers, they want to write in Python, right? And in another team, probably there are more, R developers, and, probably they want to go forward with that. So what happens is when we come to the concepts of creation of operators or working at the modular level, right? What happens is there are different sub-engines which are within DI, right? These sub-engines are exclusive, that they run within DI only, right? And so what do they do? So for example, let me take the example of a Python operator, right? So very basic Python functionalities will be available in any custom operator. You don't need to do much, right? Very basic. But for example, you need to access HDFS storage, right? So you will be using import HDFS. Then probably you will be using the insecure client class in that, right? So how do I ensure that multiple Python packages are there in my environment? This is where the creation of custom Docker file comes in, which is the first topic which I will take when we start with the modeler, right? So once you have a custom Python, custom Docker file, you assign that Docker file to your operator. Because I know this operator needs special things. How do I ensure that it has the basic environment to run, right? Pandas, scikit-learn, all those things. How do I ensure? So that is the environment. So what will happen is in modular, if you do not have do not have. So in a basic graph, right, there is a default engine which is always there. Default engine processes any and all operators, right? First, basic. So I am talking from a hierarchy perspective. One is the default. For example, a message generator. It does almost nothing, right? It just outputs messages, spits out messages. You can write a custom code and it will start spitting out messages. So this is managed by what? A default engine. But now, as we spoke, let's take an example of a Python custom operator where we have written a lot of Python code. Now, how do we handle this? Probably Keras or something else, Google Scikit-learn we are having. How do we handle? The moment we assign a Docker sub-engine, right, what happens is on anything within that operator will run in its own Dockerized process. It will run in its own Docker container within DI. Right? And as I said before, this is a pure microservice architecture. So through the NATS messaging system, this is a middleware to communicate between different processes. So the default sub-engine, for example, you are out from the output port, you are sending, string messages or message type or CSV type, whatever, right? This will be sent as messages to the Dockerized environment, which has our Python code, which will run. After that, it will push on to the next operator. Whether that next operator is in C++ sub-engine, whether it's in JavaScript sub-engine, or whether it's in Golang sub-engine, we don't need to care. This level of orchestration and creating environments for execution is what DI does as a single piece of architecture and software. It handles the switching of engines for active execution and also the sending of messages, that is your data, between different operators, and it finally gives you the output. Similar thing is for the terminal. Terminal is, you don't need to have special for terminal, right? It is handled by the default sub-engine. So there are mainly 4 sub-engines in DI. One is C++, one is Python, one is Python, ABAP, one is ABAP for handling the entire ABAP operators, right? And one is the default engine, which handles everything else. So JavaScript, as we know, JavaScript doesn't need any fancy packages and all. So JavaScript is handled by the default sub-engine. So I will show you. So we will be starting from pure scratch. So this was also I was about to cover. But this is the environment. This is how the environment is built. For us, it is just a web page where we drag drop. But it is not that simple in the background. That's the whole point of creating graphs and custom operators. You can reuse them into anywhere. This is the funda of user workspace and tenant workspace. So for example, this is also something we'll cover in the the user management and the other areas, because whatever you develop in your workspace, nobody else can see in the entire company. Even if it's apart from the tenant admins, nobody can see, right? And only if you push your data at the tenant level, only then other people can see your code, your piece of code, your piece of graph, your files, whatever. So this is a way of maintaining, whatever you are developing, it's completely yours. Nobody else can see it, unless it's a cluster admin, of course, who can manage everything, every file there is in the persistent volumes. So another important thing, which we didn't go through. So, whenever we start with an installation of data intelligence, right? So what usually happens is there are persistent disks which are also created to store all of this, right? Because DI is a software, right? So that is all it is. But to make it function properly, we need Kubernetes systems, right? But do Kubernetes systems come with 200 GB disks? No. So this is where it's always in these public clouds, right? We have to provision storage disks as well. And those storage disks are SSD, not the HDD ones. It only works on the flash drives, SSD ones. And we yes. And what happens is, as soon as we give, 3-4 disks to DI to use, what it will do is it will take them, it will partition them, and it will assign spaces for each module. It will keep assigning spaces. It will reserve space, persistent storage. And in fact, we can even see this persistent storage when we will be working with the operators and other stuff. We can see where it is getting stored. It's not getting stored in a VM's C drive, VM's D drive. No, where it is getting stored is, we are creating proper disks, E class, E1 class, E2 class, P1 class. So these are really, big IOPS sturdy disks. For example, I think the Azure E1 class has like 10,000 IOPS per second speed and such. So I mean, so this software is really, really complex. We can go into any depths, but the way it works is, we have the software, we get the pods, but for the pods to work, we need persistent storage. These persistent storage come from the storage accounts, again in the public cloud. And I think close to 100 GB of 3 or 4 disks might be there as a default, but of course we can increase. Once we increase and assign, then it's up to the DI responsibility how it uses it, right? So it's a pure, we can call it SaaS, but it's actually PaaS, because it's giving a platform to work with, right? It's not a software which you just consume at the UI level. It's a platform which is given to you, so you can change, modify, add, delete as per your needs, and then start your work.
Okay, cool.
So I know I threw a lot of cloud related terminologies here, but these are just how it is built: persistent storage, storage accounts, and Kubernetes, and the space to execute Kubernetes commands. Apart from the memory, we need to have storage also, right? For example, the graphs that we create in Modeler, these are stored where? These are stored in all this persistent storage only, which are created and aligned and used by all these pods which we see here.
Yep. This is cool to see that actually, like how that's behind the scene it is there at least right now. So we haven't seen the other side of the fence, so it is cool. Again, like I don't know anyone have any other questions, so just don't want to check them.
Any questions? Anyone else? Yeah,
Murli, doubts are really, really good. This is where exchange of information happens, and it sparks thinking in the other people as well. Those who might not have thought of this, now they are thinking of it. So I think it's a good thing.
So what I did in the meantime is, I had deployed my YAML file to the Kubernetes cluster. Okay. So how did I deploy? Now, let me go to, first I had created the deployment file. Okay. So now the nano deployment.yaml. Okay. So this is the YAML file that I was talking to you about. We have the API version, and this API version is app/v1. So this might be constant and sometimes, and this might depending on the deployment, this might also vary, so we have to be a little bit careful with the API versions. So we have the kind as deployment, because this is a deployment, we are going to deploy an application, and the name is Nginx deployment, and the naming is app is Nginx. Now if you're able to see, spec replicas is 3, correct? Replicas is 3. Now what I did is replicas is 3, and these are all some template metadata. Now the specification containers, I need to have the Nginx container pulled, and I need this image to be deployed in all the 3 available pods. I mean all the 3 pods. So previously when you do kubectl get pods, you will not have these 3. You will have only the kube system, which by default comes with the Kubernetes software, right? Now, when you deploy it, how do you deploy? You go to this command kubectl create -f deployment.yaml. Okay. So when you give this command, what it does is it will deploy this particular YAML file to the Kubernetes cluster. And then when you do this command kubectl get pods -all namespaces, okay, you will be able to see all the pods. Now we have 3 pods here, right? So how did we have 3 pods? Because in the replica we gave 3 pods. If you give it as 5 pods, then you will have 5 pods here, right? So in a similar fashion, you can delete this deployment if you don't want, and then you can redeploy it again. So how we can check whether it is working is, so probably you can hit the Nginx server and check whether it is working, but unfortunately the port is being blocked and I'm not able to remove it. So let me try out some other way, whether if it is working or not. Just give me a second. So I will just do
port 80. Okay, so some port issue. I know I'm not able to remove this, but yeah, your Nginx application is successfully deployed on this particular pod, and then it is running. Right. So this is what I wanted to show you all about. This thing, Kubernetes and Dockers. And yeah, I think one more thing, which just give me a second. I think I have not created service. Let me try that method. So we have Kubernetes. By default, we have a service. Just okay. Put some. I'm not able to something. It's basic issue. Okay, so I'm just trying to create a service mode, but probably some command issues. I don't recover. I don't recollect the command. Fine. I mean, so what is it that you have to do is, I mean, now we have the Nginx deployment. We have 3 pods, correct? Now, when we go back to our diagram, just give me a second. I'll just switch to my whiteboard so that we have a good understanding. So now, what is it that we had done? Yes, we have our node, correct? Now, using the YAML file, we have deployed our file to the Kubernetes cluster. So we have 3 pods, correct? In the replicas, we had given 3 pods, and the image is Nginx. Now, we have 3 pods here, okay? Now we have 3 pods here, right? So this is Nginx, same image, Nginx, and we have Nginx. Okay. Now, what did I tell you before in our previous discussions? Now we have the pods, we have the image sitting inside the pod. But as a business end user, if I have to hit the URL, how will the Kubernetes cluster know that I have to retrieve, I have to attack this pod and then get the image? So we need to have a service. So that is what I was trying to create, but some command issues are there. Probably I've forgotten the syntax, but I'll later let you know. So usually the command to create a service is kubectl create service node port. I'm creating a service of type node port. There will be different services. One is node port service and another one is load balancer service. I don't want to go in depth, but node port will allow you to open a particular port. Say for example, if it is 31251, this is the port. This port will be opened on this particular node, and then you will be able to access the image via this particular port. That is what node port does, opening a particular port in a node. That is why it is called as a node port. So I have to create a service of node port type so that it interacts with my images. And then if I give ZaranTech.com :31251, I will be able to open up the web page that I had deployed in my pods. Okay. So guys, this is what I wanted to show you with respect to Kubernetes and Dockers. There is something that I am missing. Yeah. Okay. So from data intelligence perspective, let me quickly show you. I will try to show you what are all the images that gets deployed into Azure Container Registry. So sometimes, for the deployments for this particular installation, what I had shown you, I think I have used Azure Container Registry to store all the images from SAP repository. I'll just quickly show you that as well. Yeah, just give me a second. I'm just opening the Azure Container Registry so that you will have an idea how many images are available with respect to data intelligence. The Azure Container Registry. So you see, you are able to see the number of images that are already available. We have a storage gateway image. We have a Axino service image. We have a integration image. We have a in case if you have to go for extended edition of installation rather than the basic editions, then we'll have something called as Grafana and Kibana for monitoring solutions. And we have a HANA image. Did you notice here we have an HANA image? And when we were browsing through the pods also, there was one particular pod which was showing as HANA-0. So we have a specific or dedicated pod which is running for HANA. Now you will be able to log on to that HANA instance also from your HANA Studio. You can connect to that and you can work on it. So because the underlying database is HANA. Now we have, you see how many images? So many images, so many. Okay, so this is what I wanted to show you there. Now let me quickly, so this is the Docker slide which is available and which will be sent to you. I'll just quickly take 5 or 10 more minutes to explain you what is there in this content, right? So we have some pictorial representations and we have the metrics. Say we have the container. So why actually the container? Why it is named as container? Because so this container will fit everything. If it is a piano, car, or whatever it is, you can use this container to fit everything, and then you can deploy it anywhere you want. If you have to transport it via roadways, yes, this container can be used. You can put it in the goods train and it will go. This container has to be shipped in a ship. Yes, put it in the ship, it will go. So that is why this naming terminology of container had really come, right? If you see here, one ship carrying multiple Docker containers. So one source, multiple containers. So, and it will have everything that you need. It wraps a piece of software in a complete file system. That is what I had explained to you, right? So whatever I had explained to you is already available in this slide. We used to eliminate the works on my machine problem. It doesn't work on my machine problem. So, what is the difference between, the virtual machines and the Docker containers. So as I have told you, this is a virtual machine and we have the this is on the left hand side, we have the Dockers, on the right hand side, we have the virtual machine. We have the differences and why containers are lightweight. So we saw, right, the container was just around 78 MB. Why was it like that? And how to install the Docker, how to run the Docker image, and all those stuffs are there. And some customers who have already implemented this particular Docker. Okay, so we have all the things that are required in this particular slide, and you can go through it. And let me go to the Kubernetes slide. And so this is also a little bit exhaustive, and Kubernetes slide also, this is the DI slide which I was just showing it to you. Let me open the Kubernetes slide. Yeah, this is the Kubernetes slide. Why Kubernetes, how it is from traditional waterfall model, how we are going or moving towards a DevOps approach, right? So, and traditional deployment, container deployment, and Kubernetes introduction. So the actual structure, starts from what is the difference between Docker's, containers, and Kubernetes, the basic concepts, and what is a pod, what is a deployment. So how do you create a deployment, how do you update a deployment, and how do you pause or resume a deployment. And then this is the YAML file that we have been discussing about. How do you deploy the YAML file, what is a replica set. So when I say 3 replicas, the 3 pods will be automatically created. So how is that happening? And then we have rolling deployments. So some of the useful commands are already here, kubectl get deployments, get pods. If you want to edit the deployment, you can just give kubectl edit and the deployment name. So you can go through these useful commands, right? And what is a service? How do you expose, the network? How do you expose the images running inside a pod? So how do you deploy the service? So all those things, whatever we had discussed. What is an ingress controller? How it is, why it is used, right? So whatever we had covered, whatever I had explained you, so it is already available in this particular slides. Okay, and on top of it, we have also seen a live example of Azure container instances and AKS, Azure Kubernetes services. See, because when I deployed Azure Kubernetes services, you did not know anything, correct? What we did is I just used only the jump box. Apart from that, I did not do anything. Where is the master? Where is the slave? Do you have any idea where it is? Or did you guys see where it is? Where is the master node running? Where is the slave node running? Do you know where it is? No, right? Have you ever seen? Guys, I was showing you Azure Kubernetes services. I was showing you to access the Kubernetes cluster from a jump box. Correct? Now, do you know where the master node is residing, where the slave node is residing, what and all the configurations that have taken place in the master node, what are all the configurations that have taken place with the slave node? You are aware of all those steps? No, it is totally abstracted. That much flexible is Azure, AWS, and GCP. They have totally eliminated all the complexity for you. Now, if you don't want to use any of these public cloud vendor Kubernetes services, absolutely fine. We have an extensive documentation prepared, which is available in the Kubernetes as well. How do you set up your own machines to set up the entire Kubernetes from scratch? How do you install a master node? How do you install a slave node? What are all the configurations that you have to do? How do you join the slave node? How do you deploy the file? Everything manually. So you have all the flavors. You want to learn Kubernetes in depth, in and out, go for that. Go for a scratch deployment, right? So you just wanted to see how the Kubernetes is, and you just want to deploy a YAML file and then play around with the application. Just go for AWS or Azure, deploy an Azure Kubernetes services, deploy the YAML file like how I had shown you, and then enjoy your application that is running on the Kubernetes server. Okay.
All right, let's test your knowledge. Here's a question for you. Which of the following is not a data source that can be connected to SAP Data Intelligence? Option A, relational databases. Option B, Hadoop clusters. Option C, cloud storage services. Option D, mainframe systems. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of managing supplies? Our SAP Data Intelligence course is here to guide you through. You can tackle it at your own pace right here on our platform. In this course, you'll explore SAP Data Intelligence, which is like a toolkit for planning things, ensuring we have enough products and getting them where they need to be. From the basics to advanced strategies, we've got you covered. Our experts crafted this course with their wealth of experience. Your instructors are seasoned pros, dedicated to helping you learn and addressing any questions you may have. And guess what? Our students rave about how helpful this course is. Folks just like you have found it incredibly valuable. And the best part, it's super affordable, so you won't have to break the bank to learn. Ready to become a SAP Data Intelligence Pro? Sign up on our page now. For more details, visit ZaranTech's website.
It is always good. I mean, this is my personal suggestion. So probably if you have your credit card, right? So what you can do is you can actually open up an Azure or AWS account using your own credit card. So do not worry. I mean, you will not get charged because there is something called as free tier concept in both AWS and Azure. So once you spin up a virtual machine or once you use all those steps which are allocated within that free tier, you will not be charged to your credit card. So this will give you a very good advantage of spinning up, say, a virtual machine, and then probably the commands, whatever we had executed yesterday, right? So you can try to execute those commands, install Docker, and do all those stuffs. So, and I think Microsoft gives you a credit of 13,000 rupees, which if I have to translate to USD, it will be close to about $200 per month. And you can use all the resources, whatever resource that you want for the $200. Until your $200 is going to get exhausted, you can use that. You don't have to worry that your credit card will be charged. So suppose that your $200 is going to cross, like you're feeling that it will get crossed, you don't have to worry about that also. As soon as your $200 is over, all your resources will be shut down. So you don't have to be in apprehension that my credit card will be charged if I don't maintain it or use it. So this is just for practice purpose, right? So just if you have your credit card, you can get started. So you don't have to wait for the actual systems to practice on Dockers and other things. So it hardly takes 5 minutes for you to register to Azure and then get started with the Dockers and the Kubernetes stuff, right? So this is what I wanted to tell you before I start. I'll just quickly recap whatever we had covered, and then we will continue our discussion from there. So we saw introduction to DI, right? So we saw introduction to DI, and we saw why data intelligence, correct? Why data intelligence has been created by SAP, what are all these advantages and other stuffs. We saw architecture, right? We saw the high level architecture of DI. Now, then we saw Docker images, right? So how to build a Docker images, how to run containers, right? And then how to push the images to the repository, right? Push images to repository. Then we saw Kubernetes. What is a Kubernetes? It is a container orchestration tool. And then we saw an example of example deployment also we saw, right? How to deploy your YAML file to the Kubernetes cluster. What is a replica? So architecture, right? And we also saw the actual pods available in the installation, in the DI installation. What are all the pods that are available, right? So these are all some of the basics that we had already gone through, right? So in case, if you have any questions from these topics, just let me know before we move on to the next topic, or else I will start with the next topic, connection management. And before that, I will just place the agenda here, what we are going to cover. Any questions from anyone from yesterday's topic? Okay. I will take it as a no. Then we will move on to the next topic, that is connection management. Okay. So as soon as we are done with the connection management, we will move on to SAP Cloud Connector. So how many of you here have experience with SAP Cloud Connector? I heard someone say they were working in SAP Cloud Platform. So anyone has an experience working with SAP Cloud Connector? Probably for others, I'll just tell you why it is used for, what it is used for, what are the configurations that has to be done, because this is also, it's an important topic, right? Now, the main core part is ABAP integration, right? So this is again very important. I mean, everything is important, but I'm just stressing on this one. So once we are done with the ABAP integration, then we will move on to the metadata management. Okay. So what we are going to cover in metadata management, yes, we have already seen, some of the basics there. We'll just go a little bit in depth, and then for each and every topic, I will just show you. I have two use cases. One use case is for, say, for example, business glossary. I will upload a data set, and then I'll tell you what has to be done in a similar fashion. I have another data set for rules. So just for an explanation of the topics, I will use individual data sets. And once I am done with everything, I will do a complete end-to-end metadata management with the data sets that I am having. So that is a complete end-to-end. So assume that you're at the customer's place and you have got this data set. Now, what is it that you have to do in the metadata management using the data set? So that particular end-to-end cycle, I will show it to you, right? And if time permits, right? So this is probably the first half, okay, and this is probably the second half. So this is the agenda that I had prepared, but in case if time permits, if we have some more time, then what I will do is I have already prepared a data set for you, okay, custom data set. Now if we have some more additional time, then I will share or upload this custom data set so that you guys can work on this data set. You can do the data preparations on this data set. Whatever I'm going to show you, you can try your hands on during our session itself. Okay, so all good. Shall we move on to the connection management now? Now, what is connection management, right? So can anyone, unmute yourself and tell me the process of how do you connect to a database in data services? Anyone? What is the process that you would be following? If I have to extract data from SAP HANA or SQL Server, what is the first thing that you do? You have to establish or build a connection, right? So how do you do it in data services? I wanted to know the process, how you do it in data services. Okay, so create the connections, and what are all the details that you will be giving? Host a IP address, port, username, and password, right? Yeah, and it will get connected. Now, your data services is an on-premise system, right? So, and you will be able to connect to the internal systems easily because it is available within the same network. Now, when we talk about connection management with respect to data intelligence, it is 95%, almost the same. Whatever you had told me, right? Host IP address, port, username, and everything is the same. So data intelligence administrators or other business users with the necessary privileges, they will be able to create a connection management to the required application. They will be able to maintain the connections also. So I am saying administrators or business users with necessary privileges. Now everyone will be able to see all the connections that is available in the data intelligence system because you all have the administrator privileges. But there is a way we can restrict the things so that only these many connections will be visible. Okay, so some of the connection management items that we can perform, right? Some of the connection management items that we can some of the connection management actions that we could perform in data intelligence. So what are all the action items that we could do? So we will be able to create the connections, right? I'll be able to create a new connections. I will be able to filter the connections, right? And I will be able to edit the connections, right? So now this is important and this is important, right? I should be able to create a new connection. I should be able to edit the connection. Now, as usual, I will be able to delete the connection if something is not working and I need to remove it. Yes, very well. And then the best feature is I will be able to import or export connection status. Okay. So now what do you mean by import or export is if you have already created the connections, say for example 10 or 12 connections, you can export all these connections from one tenant to another tenant. You can reuse the same connections in some other tenant. So what me and Ganesh, we used to do is for the internal systems, right? Sometimes if we have to test the customer's environment, internally we have our own partner tenants. And then in one of the partner tenants, we just import the connections, whatever we had done in our probably development tenant, and then we just export it and then we import it in the partner tenant. So as easy as it is, like within few minutes, all your connections will be up and running. You don't have to go and create all the connections again and again, right? So let us quickly get into the action. I will show it to you in the system how we will be able to create the connection. If you log into the system, this is the screen. This is the home page that you will see, right? I hope everyone would have logged into the system. Now, if you see here, we have various styles, right? So we have modeler, we have Metadata Explorer, we have monitoring, and then we have connection management, customer data export. So each of them, if I have to correlate to what I had told you yesterday, each of them, they represent one or multiple images, and they will be residing in a single or multiple pods, right? So even if my policy management is not working, my Metadata Explorer will still be working. So these two, as long as they don't have any strong interdependency, they should work on the individual basis, right? So let me quickly go to the connection management now. So I click on the connection management and my connection management will open. Now you are able to see all the connections that are already available in the system, right? So we just have to set up the pipeline modelers and few graphs. So hence we had created few of the connections beforehand, right? So now how do you create a new connections? As soon as you come to this screen, is someone asking a question? Ganesh, can I just check the chat? Is someone asking any question? Now, when you come to this place, right, connection management, now what is going to happen now? you will be, if you have already a predefined established connection, so in some other tenant where everyone else is working, you will be able to see a lot of connections, right? So we have connection types, we have connections, and then we have certificates. So we'll just go to connection types. Looks like the system is a little bit slow today. Yeah. Okay, so these are all the current connection types that are supported by SAP Data Intelligence. Okay, now we'll just go through a few of the connection type. Number one, ABAP connection type. Okay, so this is very important because you will be using ABAP connection type to connect to your on-premise or cloud SAP systems. Okay, ABAP-based SAP systems. Now we have Azure Data Lake Storage, and then we have Azure Data Lake Storage Generation 2. This is for the older generation. This is for the newer generation. And in case if you want to use a simple notification service from AWS and then use that to trigger some pipeline, you have the AWS SNS connection type here. And then you have the SQL database connection type. And then you have BW connection type, right? So depending on your requirement, you have a lot of connection types here, which is more than enough for the current organizations to connect to the desired data source, right? We have the HANA connection type, we have Google storage, we have S3 storage, we have MySQL, we have SQL Server, Oracle, right? And then we have Vora also. So Vora database is something, if you choose to install SAP Data Intelligence full stack, it will also come by default, and then you will be able to connect to the Vora database, right? And we have Azure Blob Storage as well. Now, these are all the connection types which you can see, which are supported in Data Intelligence. Now, how do you create a new connection, right? How do you create the new connection? So I go to connections. I'm able to see all the created connections here. Okay. Now, if I just have to check whether the connections that are available here is working or not. Okay. What I have to do is, say for example, I just take this particular storage account connection, right? I just click here and then I just check the status. Now it will check the status. So connection ID is this one. Now, this is a little bit secure. When I say secure, if I say that I don't want people to see the credentials that I'm using within a connection, is that possible? Yes, it is possible, because so I use Azure storage account for the connection. This is a successful connection. But when I click on this edit, right? See, when I click on this edit, it will take me to the screen. And then you see here, account key, it's blanked out, right? So account key is the important factor for connecting to the storage account. Without account key, you will not be able to, connect to this blob storage. So not only this, any account, any connection for that fact. Now I have the HANA connection detail. If you want to play around with the connection management, what I would suggest is HANA database. Anyway, the details I'm going to give it to you. Number two, I will show you a mechanism how we can connect to Windows Azure storage, Azure blob storage. So if you can just create your Azure account and create the blob storage the way how I'm going to explain you now, and then you can use it, upload the files in your own blob storage account in case if you want to use it, or else you don't have to worry. You can use the existing connection also. Okay, you can use the existing connections to upload the file and then use it in the metadata and all those stuff. So if you want to just practice, then you create your own account and then use this connection management to connect your data lake or to connect your Azure blob storage, right? So we will proceed. Any doubts till now? No. Okay, so I have my database already connected, so I'll just check the status. I hope my HANA database is working. Now, if I have to edit this connection, right? I just click on edit and then I will modify whatever I want. Now, if you see, the username and the password is grayed out. Okay, so this will be the IP that you will be using. And this is the port number that you all will be using to connect to the HANA database. And I will send you the user and the password after the end of the session. Okay, so now I'll just click on cancel. How do you create a new connection? You just click on plus. Now, the first thing is the ABAP connection that it comes here. Now, ID, I would give any ID, right? My ABAP. or it could be, my ZaranTech TCS connection, some ID just for my differentiation, and then the description, and then we have the protocol, right? So we have WebSocket RFC, we have HTTPS, and then we have the RFC protocol. So predominantly we use RFC connection, and for S4 HANA, we can either use RFC or we can use WebSocket RFC connection to connect to the systems. And now, what are all the details that we have to give in the RFC connection? We have the system ID. Say, for example, it is PAS, and then we have the application server, which is nothing but your host name. Say, for example, it is test.appserver.com, and we have the system number. So by default it will be 00, and we have the client, and then we have the username, standard user, and then we have the password. So that's it. It's very simple. This is what you have to give.
Is that something we have to always go with RFC connections for the or do we can go in either protocols?
No, you can go with any other HTTPS or WebSocket RFC also, but it is always recommended to go for RFC because the performance also will be very fast, and then the SAP notes, whatever you're going to implement, it will have some specific steps that you have to do with RFC and WebSocket RFC, right? So depending on that, you can go for either RFC or HTTPS. But from our experience, whatever customers that we had worked with, they had easily gone for RFC connection. Not seen, at least as he had told, right, majority of the customers, at least 90 to 95% of the customers, we didn't even look at HTTPS. We just looked at only RFC because customers also wanted with RFC only. So we really did not even go to the HTTPS section. If you're going to expose it, then probably HTTPS is the right protocol. So I'll tell you why. Because if you choose this HTTPS protocol, automatically you will not get one option here, right? So here we have only change note and tags. Now I'll tell you one more thing. If I go for RFC, I'll be able to see one.
Yes, sir.
Gateway host. Oh, sorry. It will not come here. Yeah, the gateway host. You're absolutely right. It is not getting displayed here because whatever I'm using is an on-premise version. So this will be available in the DI Cloud, right? So you have to, because right, why it is used for, because basically for exposing your internal systems to other. But normally, as you had told, right, for the API connections and other stuffs, you can easily use HTTPS protocol, which you will be able to expose it over the internet and connect to those applications. I don't think that shouldn't be a problem.
Okay.
That is definitely not going to be, because this is very flexible. That's why they have given all the three protocols. In case if you want to be secure, you can go for RFC and WebSocket RFC. If you want to little bit expose something over the internet and where you want to consume the APIs, then you can easily go for the HTTPS protocol as well. So this is what had been designed. But I have never configured this HTTP over the internet for any API access, because I have not done that actually, because majority of my experience is revolving around RFC only.
Okay.
But if you want, I can just fetch more details. Probably I'll just try to get some customer cases. It is very hard, to get a customer case with HTTPS connected.
I know. But it's coming. But I'll trust me, it is coming.
It is coming. You're right. You're absolutely right. We should also be equipped. Yeah, you're right. I'm 100% sure. I know that this could be done, but the thing is, it has not been done because we have not got any such requirements. That is the only reason.
Yeah.
Right. So I will try to get more details on this HTTPS, but as of now, probably you can, just get the differentiation as secure, and then in case if you have to connect to the cloud connector and then connect your on-premise system, you'll be able to use that. I will also try to open up, some of the systems in the cloud version, and then I'll just try to show you how the gateway and all those steps when I take up the SAP Cloud Connector, right? So I'll just show you all those steps. What are all the things that are available there? So. This is the ABAP connection type. We have three protocols and system ID, host name, and all the steps are already there, right? And here you can select which connection type you want. If you want to go for MySQL, SQL Server, whatever it is, you'll be able to do it. So if I choose Azure Data Lake, generation 2, I'll be able to create an account. Now, I'll just quickly, for demo purpose, I'll just open up a storage account, and then I will just show you how to create a storage account. What are all the details that you have to give here, right? And then you'll be able to access the connection. So one trivia here is this ABAP system connection, right? So this is for both S4 and the ECC system as well. So even though, as I had told multiple times, this connection might looks very simple. So Murli, I will take you through the SAP notes. You will find all the details in those SAP notes, even with respect to HTTPS connection, what has to be done, an RFC connection, what has to be done. If it's an S4 HANA, what has to be done. Now, you are aware of the fact that if you have to connect to ECC system, the ECC system must definitely have SAP DMIS add-on. Are you aware of this fact?
What is it?
DMIS,
Oh,
DMIS.
okay.
So
No,
for SLT,
I
you will be you have experience in using SLT. For you to access SLT, obviously the DMIS add-on is already available, because without DMIS add-on, you would not have been able to access the SLT system. So so these are all some of the considerations. I will just cleanly put it out on the whiteboard, and I will just tell you, so that next time if you have to establish a connection with S4 HANA system or ECC system or even BW system, you have to take this into consideration. Directly, if you go to this above connection type, give the system ID, host name, port number, I'm sorry, it will definitely not work. And it is an extensive effort, Murli. I mean, you have to sit for a day or two with the basis colleagues and then upload all those SAP notes and then check whether these SAP notes are uploaded properly, and then you verify it, and then you come here and then you test the connection. Even then it will give you some error, then you have to debug little more and then see what is the error, and then you have to do all those steps. But don't worry, I will detail you the steps, right? I will be based on our experience. I will detail you the steps, what or from where you have to start, where you have to end. So that is the entire process, right? So I will tell you everything so that your ABAP connection will be made easier. Probably for rest of the connections, it is pretty straightforward, like HANA DB, data lake, data storage, and even if you want to just see the connection type of data services, you have the CMS host, port, username, and password, right? So if your CMS host is exposed, then I think it should be working directly if you give it here. But if your CMS host is not exposed, then probably we need to find a way how it could be exposed via proxy server, and then we have to give that here. So this is also pretty straightforward, though we have to see in case if we encounter any error. If I had a data services system, then probably I would have told you all those things, but unfortunately I did not have the time to create or deploy the data services system and then show to you all these stuff. But day 4, I will try my level best. At least I will try to get these connection details, and then I'll just, at least pictorially, I'll just show you what has to be done. I'll just get you the snapshots. At least this is the configuration that has to be done. This is what has to be installed, or if something specific is there, right? So I'll just try to show that on day 4. So now, shall we just go ahead and quickly take some time to create a storage account, and then so that you guys are, you get a good understanding of how to create this connection, right? Just give me a second. Now, what is a so this is your Azure portal, and this is a storage account. So in Azure, you will have a search. Just search for storage account. It will directly take you to this page. Now I'm clicking on add. So I'm just creating a new storage account, right? So I'm just giving the subscription. I'll just create a new group, my data lake. Okay. Now you might be wondering, I'm creating a storage account, why I'm giving the name as data lake. Actually, I'm not creating a storage account, I'm creating a data lake. It is just a very simple feature in Azure. It will, based on that feature, it will decide whether it is a data lake or it is a Azure storage account. I'll just show to you where it is. Now my storage account name will be like my demo storage account 123. Right, so this is what I will give. Azure will check the availability of the storage account, and then it will give us a tick mark if it is available. Some standard region I will just choose, and then I will choose the V2. If you go for V1, then we have 2 connection types, right? One is for V2 and one is for V1. If your storage account or data lake is created based on V1, you have to go for the V1 connection. Now we have the V2. Okay, so now I'll not explain the redundant replication and all those steps. Probably it will be way above the boundary for you guys. Okay,
Venkat, can you please repeat V1, V2, when V1 and when V2?
Okay, so this is nothing but you have a general purpose V1 version 1, and this is version 2. version 1 is the older version of the Azure storage account, wherein some features are not supported, and it is probably the older versions, right? So people are using only V2 nowadays. So this V1 is only for people who had been using Azure for like 4 or 5 years back, where they had already created the V1 storage account and they have multiple files already stored in that V1 account, and they want to utilize that. So that is on. For us, for you people, it is always V2. Don't go for V1. This is also the standard recommendation that is provided by Microsoft themselves. It's an official recommendation from Microsoft. Please go always with storage V2. So this V1 is only for people who have already, created a lot of files. Say like there is queues, there is tables, there is blobs, there is file share. So this is for people who have already working on this V1 for more than years and they have n number of files in that storage, right? For other people, please it is go to V2, and they are also advising the customers who are already there in V1 to upgrade to V2. There is a provision Microsoft Azure gives you to upgrade V1 from V2, right? So as of now, you just consider this as obsolete. Okay, this is not in space. You just keep in mind only V2 is there. Okay, so now it is just the version 1, version 2, version 3. You'll have multiple versions of a file, right? Or multiple versions of a software of your application. So you have iOS 11.0, iOS 12.0, similar fashion. Android Jelly Beans, Android other, probably some other thing. So similar kind of versioning. Okay, so networking I will not explain. Data protection. So these are all cloud concepts which I will not explain. Now, so this is the place where it determines whether your storage account is a data lake or it is a blob storage or it is a proper Windows Azure storage blob. So now what is the difference between WASB, WASB, Windows Azure Storage Blob, and your data lake? So when you check this, right, when you enable this data lake Gen 2, so this storage account will not be WASB, it will be your data lake account. Now, what is the difference between WASB and data lake? Is your data lake will be able to support files like Parquet, and it is based on HDFS, right? So if you have so these kind of files, streaming files will be supported by this data lake, whereas WASB, it also you will be able to copy and paste it manually, but still from analytics point of view, from integration point of view, it is not that much supported if it is a normal storage blob, right? And when you have a data lake, you will have a very good seamless integration even with analytics, in case if you have to process these Parquet files or the file which supports HDFS format and all those stuffs, right? So I am enabling this as a data lake. I am just clicking on next. And how do I relate this with data intelligences? So if I create a connection type as data lake, then probably I can also put all the streaming files in this data lake and then use it for processing. So my data scientists can easily take all the data from this data lake, and then they will be able to create models. So this is one use case with respect to SAP Data Intelligence. Okay, so I'm just quickly creating the storage account. Yeah, so my deployment is in progress. It will hardly take 1 or 2 minutes. Then we'll quickly go to data intelligence and create a sample connection. Right, so these connections are already intact. Okay, so you don't have to, this is just for your understanding, I'm telling you, this is how you have to create a connection in data intelligence. But you don't have to worry, in case if you're not able to create an account in Azure or AWS, still it is fine. You can use the existing connections, whatever we have in data intelligence, to upload your file and other stuff. Okay, so I'm just going to the resource, right? So this is my account name. So this is my account name, right? And then this is my access key. Okay, so I will just put it in a notepad. I'll just put it in a notepad because this is what we will be giving it in data intelligence. So my account name is this one. My account name is this one. Now this is the access key. Usually no one will have access to this access key except for the administrators, because this is highly sensitive. If you have access to this key, right, then one can do anything in this particular data lake. They can delete, they can modify, do whatever they want. So that is why this is very, very, very sensitive, and not many people will have access to this, right? So I'll just copy this access keys and then I'll just paste it in my notepad. Now let me create a sample container here. Okay, I'm just going to the containers. Now don't confuse this with the container whatever we had discussed yesterday. This container is just like a placeholder, just like a folder, in case if for you to easily understand. This is like a folder structure. Now I create a sample folder Venkat. Inside Venkat, I will have multiple files. It's just a folder structure. Just imagine that way. Now, so I have my container. I'll just say Venkat container. Okay. Now I'll just give a public level access here so that we see everything is working. Now I'll just create a container here. Done. I will just note the name of this container. Now, if I go inside this container, I'll be able to upload all the files that I require. So if you have CSV file, you have TXT file, you have Parquet file, whatever it is, you'll be able to upload it manually also inside this container, right? Say for example, my container is, if I have a container finance, all the finance related documents I will upload in the finance. If I have a container HR, all the HR related documents I will upload it in the HR container. Okay, so I will note down my container name also, and then now I will quickly switch to data intelligence connection management here, right? Okay, so now what is it that I have to select from here? I have to select Azure Data Lake Generation 2, right? And then what is the ID? I'll just say TCS or probably for easy understanding, test ADL, right? And then authorization method, shared key. Right now there is only one authorization method, that access key, and I'll just give my test Azure Data Lake account. Okay, so account name. Now what is the account name that I had given? It's my demo storage 123, and this is the account key. This is I don't give any endpoint suffix. Let me check whether it is working or not. And my root path is Venkat container. Let me check. Okay, so my connection is okay. Guys, my connection is okay. Now I'll just create the connection now. My connection is properly working. If I want to tag it, I can tag it, say like a project finance, so that people will know that this is the connection that I have related. I'm just assigning it to project finance. Okay. Now let me just create the connection and then check whether it is reflecting here or not. Right, let me do a refresh. Yeah, test ADL, right? I'll just check the status once again, and I have created the Azure Data Lake connection. So in a similar fashion, if you want to create any connection, you can just do it. If you want to create a Windows, this WASP connection, Windows Azure storage block. So I had shown you one option, right, where it will consider as a data lake. If you just deselect that option, it will become the storage account, so that you can choose the type as WASP. So WASB, and this is the Windows Azure storage block. Okay. So any doubts here? Any doubts? This is how you have to create a connection. And there is also one more stuff here. We call it as certificates. Okay, we call it as certificates. And in case if you are using this HTTPS request, right, and if you have a valid certificate, then probably you can just upload it here, so that DI will be able to authenticate that it is receiving the right request. So this is the place where you will have to upload the certificates, and then this is the place where you create the connections, and then this is the place where you can see all the connection types. Okay. Now I had told you whatever we had seen is yes, Murali.
Yeah. Yeah, it's Ganesh here. Yeah.
Oh,
Just
sorry,
to add,
Ganesh. Yeah.
yeah, just to add in here, right? So in the certificate section, it's like not. So right now you see the data hub certificates, right? But what will happen is, for example, in a proper enterprise scenario, You might be, accessing different systems, upstream, downstream, etc. And where you might need a lot of certificates in order to access those systems, right? So you would probably need a chain of certificates. In that case, what you have to do is you have to get that certificate and directly upload it here. Once you upload it, that is all you need to do. Whatever requests go out from DI, right? Whether it's via connection, whether it's via API, whether it's via anything. If you connect to any system, if there is a certificate lying here, it will automatically attach that certificate to the request, and the request will be, properly evaluated by the destination system. So right now, the certificates which you see are not just for the SAP Data Hub Data Intelligence, but it's also for the.
And yeah, so right now we have been seeing connection types, certificates, how to create a connection, what are all the required parameters for each and every connection type, right? And then this is how we will filter.
Yes, can't hear you.
Test ADL. All right, just search for test. Okay. So, sorry, I'm just searching in the connection type. I just have to go to the connections and then search for my connection. Test. If I give test, all the connections will be displayed here. And yeah, we have the normal filtering options. If you want to filter it based on the tags, or if you want to filter it based on the type, I want to see only the Azure Data Lake versioning 2. So you'll be able to filter it, and then those connections will be displayed here. Just click on this and the filter will go off. Okay. And one more important feature which I had written it down in the whiteboard is import or export. Just remember this. You can also have you can export all your connections and then import into separate tenants. So this is the place where you just export all the connections. Okay, so whichever connections that you want to export, you just select it. Say for example, I want only Data Lake and HANA localhost. I will export these two connections. Now this will be exported as a JSON file, and then you just have to import it again in a separate tenant. So this is what it is all about, connection management, right? So any questions? Any questions?
No, I'm good.
Okay, so now if I ask anyone to create a connection in S3 or Azure Data Lake or Azure Storage or HANA database connection, you'll know how to create a connection, right? Oh, okay, excellent. So shall we move on to the next topic?
Yep.
Okay, so now we will move on to SAP Cloud Connector. So this is also one of the important topic because in case we are not sure whether you will be using on-premise or you will be using DI Cloud version. So in case if you have a DI Cloud version, how do you connect to the on-premise customer's environment is going to be entirely different. So you are going to do it via SAP Cloud Connector because see why? Because I'll just give you an example. Now we have DI on-premise, right? So one of our customers were one of the customers that we had worked with. They had gone for DI on-premise and they were working on Azure, and we had installed the DI on Azure. And what they had done is they had using express route. There is something called as express route, which is a VPN connection. They had established an express route connection from their Azure to their on-premise data center. Hence, you don't need anything. So it will act like your Azure is also sitting on top of their data center. So it will be easily able to communicate to the on-premise data center using the express route. So ideally, which means that whatever you install on Azure also will be able to communicate to your on-premise data center, that is your on-premise systems. So DI, which is also installed on Azure, will be able to communicate to the on-premise system without any fluctuation, okay, without any problem. Because it is a seamless connection, they have already established the VPN and it will be able to communicate. But whereas when we go for a DI cloud version, right? When we go for a DI cloud version, what is going to happen is DI, if you go for a Neo or if you're going to go for a Cloud Foundry, Neo means SAP hosted data centers and Cloud Foundry is nothing but your Azure, AWS, etc. So they might have their own data centers. Our SAP Data Intelligence is deployed on the data centers. Say, for example, if I'm going to deploy it in the Cloud Foundry, probably the region would be Europe or US, depending on the region that you use. And obviously, you will not be able to communicate with the Europe region or US region data center where DI is deployed with your on-premise data center, correct? And you also don't want to do it because that data center is somewhere hosted, someone is taking care of it. You also do not want to do that. So that is where for DI Cloud, for securely accessing your on-premise SAP systems, we have SAP Cloud Connector. Okay, so I will just open up my white. If DI is an on-premise, obviously there is no need for your SAP Cloud Connector. But I heard one of your team member is working on SAP Cloud Platform, right? So leave out DI. I mean, SAP Cloud Connector is common for all the things as well. So in case if they have to integrate their SAP Cloud Platform application with some other on-premise application, obviously they need to use SAP Cloud Connector, correct? So this is very important. And tomorrow, in case if you're going to work on any projects wherein you have to use DI Cloud, then you really need to set this SAP Cloud Connector. So I will give you all the details. I will tell you from scratch, how to set this up, how to do it. I also have some screenshots already placed so that whenever you have this kind of requirement, just go through this video, have a look at the screenshot, have a look at the configurations, and then your SAP Cloud Connector will be up and running. So we'll quickly go through the SAP Cloud Connector connection, and then we'll start with the ABAP integration. And then probably second half, we will sit for metadata management, hands-on. Right. I will. So now, to make a clear representation, right? I'll just put. Okay. So now we have assumed that as a customer, I have my S4 HANA on-prem system. Okay. I have my S4 HANA on-prem system. Now, this is my customer data center. Okay, which is a very security stringent one. I don't expose anything to the outside world as of now. Now my S4 HANA on-premise system, and this is the server where my S4 HANA is installed. Okay, now if I have to connect or communicate to this S4 HANA, what is it that I have to do from DI perspective, from data intelligence perspective, right? If there is a requirement for them to integrate DI with their SAP internal system. So obviously the only chances they have to go for SAP Cloud Connector. Now we have SAP Cloud Platform here. SAP Cloud Platform, right? And now we need to have a handshake between the SAP Cloud Platform and S4 HANA on-premise system. So this is the external world. Now, can anyone tell me, when we are talking about SAP Cloud Connector, we are talking about SAP Data Intelligence, we are talking about on-premise customer system. I am telling you to have a handshake between SAP Cloud Platform and S4 HANA on-premise. Can anyone tell me why? Anyone?
That is something that why we need to go with the SAP Cloud Platform. Is that what you're saying? That connector, Cloud Connector, because it's in the SAP Cloud, this is in on-prem. So obviously you will have to go through that SAP connector, right? That's the.
Yes, but probably a very basic difference, right? Not very basic difference, very basic definitions. So we have our DI Cloud version, right? Now, this data intelligence cloud version is nothing but is built on top of SAP Cloud Platform. So that is why whenever you have the DI Cloud version, you will be having an access to SAP Cloud Platform. From there, the DI Cloud version will be spinned up based on Neo or Cloud Foundry. And then the handshake has to happen between your SAP Cloud Platform and the S4 HANA on-premise. Now, this handshake will happen through the Cloud Connector. CC, I'll just put it as a CC, Cloud Connector. Right. Now, one more trivia here, probably which is not required for data intelligence, but since you guys are from development background, this will be very useful. So we have a web IDE environment, right? In case if you have to expose your OData protocol, then we need to configure something additional called as destination in SAP Cloud Platform. So this destination will have the on-prem details. Okay, this destination will have the on-prem details, so that when you expose your OData calls, it will know that which server that I have to connect to and get the OData protocol and then expose it to the external world. But for DI, this is not required, right? So now, if I have to draw a pyramid and then show you in terms of cloud where the SAP Cloud Platform. So you all are aware of this, right? SaaS, PaaS, and IaaS, right? So SAP Cloud Platform is platform as a service. When I say platform as a service, it provides you the required platform to build any applications on top of it. So DI is one of the applications which is built on top of SAP Cloud Platform. So now, so we will be able to run the applications without having to worry about the underlying infra, and then we will be, as I told you, we need to establish a handshake between the SAP Cloud Platform and the customer's on-premise S/4HANA system, right? So I probably, if I have some time, I will also show you how it looks like in the connection management also, right? So what happens is, in DI on-premise, you did not see this connection, right? So when you choose the ABAP, connection type as ABAP, when you choose RFC as a protocol, you will have another option, gateway. And here SAP Cloud Connector will be there, right? I will show it to you in the cloud if time is there. So this will be available only on two occasions. One is if it is a DI cloud, DI on-premise, you will not see this. And another one is it will be available only for the RFC connection, right? It will not be available for HTTPS or HTTP. It will be available only for the RFC connections. So only when you choose the type as ABAP and then the protocol as RFC, you will be able to configure it to a cloud connector, so that this cloud connector will be able to talk to the on-premise system and then get the data and then put it back to DI. So this is the entire mechanism. Now, how do you download this cloud connector? So why I am telling you all these things? Because tomorrow no one will come to your rescue. In case if you have to set up an ABAP setup with DI cloud, you should know all these steps and you should be able to set this up, right? So from where I can download the cloud connector? Cloud connector is an installer, okay? So I will be able to download it from https tools.hana.ondemand.com. So you go to this website and then you will search for cloud connector, right? And then it will show you various options for Windows, for Mac, for Linux, right? So you just, depending on the appropriate OS, you have to download the cloud connector. Now, one of the basic question is, can anyone tell me where you have to download this cloud connector to? Where you will be downloading this cloud connector?
All right, let's test your knowledge. Here's a question for you. Which of the following is not a feature of the SAP Data Intelligence? Data cataloging component. Option A, data lineage tracking. Option B, automated data profiling. Option C, sensitive data masking. Option D, data warehousing. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section.
This is my customer's data center. Okay, so this is my customer DC. I have my S/4HANA here. Now, probably in the same environment or even in the same box, you can install your cloud connector. Now, once you install the cloud connector, you have to access the cloud connector via this particular standard URL, localhost 8443. Okay, so this is the way how you will be able to access Cloud Connector. This is very, very simple. Cloud Connector, you just go to that website that I had mentioned you, tools.hana.ondemand.com. It will be like normal software. If you are going to download any software, right? So it will be like a normal software. You just double click it. The installer will download. Just click on it. Cloud Connector will get installed. Now, once the Cloud Connector is installed, open a browser and then go for this HTTP localhost 8443. Your Cloud Connector will be opened, and then you have to log on to the Cloud Connector to configure the settings. Okay, so now in case if customers comes and ask you, okay, because SAP Cloud Platform is something that you don't have control over the underlying infrastructure. So what will be the pricing, right? What will be the pricing if I have to look at, if you have to use this SAP Cloud Platform and all those applications, in case if I have to use, what will be the pricing? So we there is an estimator calculator, like how we have it in AWS or Azure. You have an SAP Cloud Platform estimator calculator, right? You can just go to it, and then you can put in the number of users, required parameters, and then you will be able to get the price. Just probably search for SAP estimator tool. You should be able to get it in Google. So okay, so this will tell you the pricing. Okay, now I will just go through some of the screenshots, okay, which I had configured, so that you will have a clear understanding of what it is. Just give me a second. I'll just switch to the system. This is how the Cloud Connector login will be there. So just give the username and password. So by default, the username is administrator and the password is manage. Once you log in, it will ask you to change the password. Just change the password. Now remember, very, very important thing. This has to be installed on your on-premise environment. Okay, be it in the same box, different box, but it has to be in your on-premise network. Now, once you have logged on to the Cloud Connector, you will be getting a screen like this. Okay, now just a second. Yeah, so you'll be getting a screen like this, and then first thing that you have to do is you have to add a sub account. Okay, you should be able to add a sub account. Sub account is nothing but in SAP Cloud Platform, you will already be having something called as a sub account. Probably if your sub account ID will be like, it will be like a 20 or 24 digit character, so like the 2xe512 something like that. So add a sub account, and then your sub account will be added. So you have to give the sub account ID. You will be giving the sub account region where your cloud platform is going to reside. All the details of your SAP Cloud Platform account, you have to give it in this Cloud Connector. Okay, add the sub account, and once the sub account is added successfully, you should be able to get an icon like this, right? So which means that your sub account has been added successfully to the Cloud Connector. Okay, now sorry, so what is the next step? So now my sub account is added. Okay, you see it is connected. It will show you as connected, which means that your sub account of your SAP Cloud Platform is connected. Now we have two things here. After adding the sub account, what is the next step that we have to do is we have to establish a connection between SAP Data Intelligence and the SAP on-premise ABAP systems, right? So for that, we choose the option cloud to on-premise, because we are going to integrate SAP Data Intelligence with the backend system. Okay, now if you see here, it will tell you that this thing is connected, but no active resources available. Check cloud to on-premise access control. Why? Because if I choose this cloud to on-premise, I will not have anything here. So this is the place where you will be actually configuring your on-premise system to which SAP Data Intelligence has to talk to. Okay, now I am going here. Now what I will do is I will hit on this plus button. Okay, I'll hit on this plus button to create the connection. Now add the system mapping. What is the backend type of an on-premise system, right? So if I'm going to connect to S4 system or ECC system, I'll be choosing the ABAP system. Or if my HANA is residing in my on-premise data center, I will choose HANA. So depending on your requirement, you will be able to use this. You can choose the backend type. My backend type is this is my on-premise. Okay, this is my on-premise, and this is my SAP DI. Now for SAP DI, the backend is the on-premise system. Okay, so I choose the required on-premise system. Say for example, it is an ABAP system. Then probably I choose the HTTP, or I think I had chosen HANA DB there in the previous screen. That's why the RFC is not coming. But when you choose ABAP system, you will have the RFC enabled. So just select the RFP or HTTP. The RFC connection. HTTP will be disabled. Now, once you choose the RFC connection, you have to give the internal host. So this is your internal application server. This is your internal port, right? Now this is, assume that I'm connecting to my HANA DB. I have taken the screenshots of the connection to my HANA DB. Okay, so now if it is S4 or ECC, then it will be your ECC application server or S4 application server and the internal port to which it has to connect to. So probably, and then we have something called as virtual host. Now, most of the customers, what is a mistake that they will do is, by default, if you don't select anything in the virtual host or virtual port, it will map directly. By default, it will take the value of your internal host. By default, it will take the value of your internal port. Now, the main intention, okay, behind using this, one of the main intentions behind using this Cloud Connector is not only to expose the systems to the outside world, but also to mask the IP address. I do not want to reveal my application server to the external world. So in such cases, I have to give my virtual host and I have to give my virtual port. It could be anything. This virtual host could be anything. So internally, Cloud Connector will map this virtual host to your internal host. Okay. So now this is my virtual host ID and this is my virtual port number. So my virtual host will be mapped to my customer host and my virtual port 100 will be mapped to my internal port. All right. So now I come down. Now, once I have added the systems, okay, from cloud to on-premise, once I have added the required systems, I'll be, getting these three systems. I have added three systems here, one for HANA and one for ABAP system. If you see the ABAP system, I have used the protocol as RFC, okay, and for HANA, it is a TCP protocol. Now, as soon as you add the system, right, this will be in the unchecked state. Now you have to check it. You have to check whether the connection, the Cloud Connector is able to ping your internal systems, or it is able to talk to or communicate to your internal systems. Okay, so that is where you have to click this particular button. So this is the one, right? So this is the one. Once you do it, it will do a check. And once it does a check, and it will tell you whether it is reachable or it is not reachable. Now, if it is reachable, yes, in the Cloud Connector, it is working fine, absolutely fine. Now, you remember what we did? We added a sub account, right? So in your SAP Cloud Platform, also this should be reachable. Okay. So in your SAP Cloud Platform, also we have the Cloud Connector. If you go to SAP Cloud Platform, if you go to that particular sub account, say your sub account is EX12, something like that. Click on that sub account, come down to connectivity, click on Cloud Connectors. So automatically, whatever systems that you have added there in the Cloud Connector will be added here. Okay. So now you have successfully established a handshake between your SAP Cloud Platform and your on-premise system. Right. So if I ask you to set up, SAP Cloud Connector, now will you have any hiccups, or is it pretty straightforward for you? Little straightforward when compared to other configuration settings, right? So this should be straightforward, because whatever, if you just follow the screenshots, whatever I had given, right, in case you can just try it out in your on-premise. If you have your HANA database, just give the same host, give some virtual host, some other virtual host, and do a connection. It will definitely work. If you have a Cloud Platform account, then just try to, obviously you should be having a Cloud Platform account. In case if you're going to go for a Cloud Connector, just connect, do a handshake, it will definitely work.
Yeah.
Right.
And the virtual host is something that has to be, kind of a best practice, right? So that you would not.
It is definitely. But I will tell you what is the common slip up most of the customers will do. Okay. So they will also just click on next and then they will go. What they don't know is
the system by default takes the internal one. By default, it will take the, I have modified this in my screenshot, but by default, if you hit this next, right, in this internal host, your virtual host will also have the same internal host, and your virtual port will also have the same port. So it means like you're, inadvertently exposing your application server to the outside world. So most of the customers have missed this. I myself have seen that, and I have advised the customers to change this in case if they don't want to expose this to other people who, in case, as I told you, right, if you go to connection management, click on edit, still I will be able to see the application server and the port through which you are connecting. Though I will not be able to see the user and the password, but I can see to which application server you are getting connected. Now, if I give my virtual host as something like, say for example, I just give it as in a black color. This is my virtual host. My port is something like 252. So obviously this doesn't mean anything to any of the users, right? So this is how you have to mask your internal address. Okay, so this is how your SAP Cloud Connector is going to be working, and this is the configuration that you have to do. And please remember the basic stuff. Just download the SAP Cloud Connector on the server where your on-premise S4HANA is installed. Just log on to the Cloud Connector, add the sub account which you are using for DI Cloud, and then add the cloud to on-premise system, select the necessary protocol, RFC or HTTP or TCP depending on the system that you want to connect to, and then do a check whether it is working or not. Importantly, change your virtual host and virtual port. And then the important stuff is when you go to connection management, as I had told you, right, when you go to connection management in DI Cloud, choose the ABAP connection type, choose the protocol as RFC. So that is the only one which is supported now, right? So choose the protocol as RFC and then gateway. Okay, so there will be something called as gateway host, which will have a text box for you to enter something. It is not mandatory parameter, so you can just leave it as blank. At least in most of the customer cases, we have just left it as blank. We did not provide any explicit gateway host. In case if you have a gateway to bypass, these protocols or these communications, just give the gateway host, or else you can leave it as blank. And gateway type, that is the most important parameter, guys. So this you have to select it as SAP Cloud Connector. If you don't select this, then obviously it will not work. So if you select this, then you are telling Data Intelligence to do an RFC connection, go via the Cloud Connector. And which Cloud Connector it will go? As I told you, DI is a cloud application developed on the SAP Cloud Platform. So the cloud platform where you have spinned up the SAP DI instance, it will go to the same Cloud Connector, and then it will check for any successful connection, which the SAP Cloud Platform is able to do a handshake on the on-premise system. Okay, so this is what you have to do for a cloud connection. In case if you have to connect to ABAP on-premise system from DI Cloud, this is a process that you have to follow, guys.
Hey there, ready to dive into the world of managing supplies? Our SAP Data Intelligence course is here to guide you through. You can tackle it at your own pace right here on our platform. In this course, you'll explore SAP Data Intelligence, which is like a toolkit for planning things, ensuring we have enough products and getting them where they need to be. From the basics to advanced strategies, we've got you covered. Our experts crafted this course with their wealth of experience. Your instructors are seasoned pros, dedicated to helping you learn and addressing any questions you may have. And guess what? Our students rave about how helpful this course is. Folks just like you have found it incredibly valuable. And the best part, it's super affordable, so you won't have to break the bank to learn. Ready to become an SAP Data Intelligence Pro? Sign up on our page now. For more details, visit ZaranTech's website